honorable dignitaries, learned delegates, respected teachers, and your students. Very good morning to one and all. Welcome to the day 2 of the 3 days International E-Conference, Current Trends in Waste Treatment, Reuse and Valorization. I, Ms. Purnima Bhagwat, feel privileged to welcome you all on behalf of School of Science, Sandip University, Nashik, and Society for Green Environment, New Delhi, India. We look forward to get an exposure about what the best of the brains think about this very dynamic issue of current trends in waste treatment, reuse, valorization at present and in future. Now, I request Dr. Boluram Yadav to deliver the plenary lecture as a speaker of this session, and I would like to invite Dr. Leena Patil, Assistant Professor, Department of Chemistry, School of Science, Sandip University, Nashik, as session chair. I request Dr. Leena Patil to kindly introduce Sir with us.
It is my great pleasure to welcome Dr. Bolu Ram Yadav. Good morning, sir.
Good
He
morning,
is
ma'am.
working.
Ma'am, am I audible?
Good morning, sir. He is
Hello.
working as a scientist at CSIR National Environmental Engineering Research Institute, Nagpur. Before joining the Navy, Dr. Yadav worked as assistant professor at School of Energy and Environment, Thapar Institute of Engineering and Technology at Patiala for 3 years. He received his Master of Technology and PhD in Environmental Science and Engineering from CESC IIT Bombay. After completing MTech in 2010, he worked in industry for 1 year in the area of water treatment and hazardous waste management. During the master's and PhD, he worked on the treatment of pulp and paper mill wastewater using advanced oxidation process. He has 9 research publications in the area of wastewater and solid waste management in reputed national and international journals. He is currently working in the area of waste and wastewater treatment and solid waste management. Now, in this session, he will deliver the information about the digitalization in wastewater management. So, once again, I welcome you, sir. Over to you.
Thank you, Dr. Leena. So first
Thank you,
of all,
sir.
I would like to thank the organizers of the International Conference on Current Trends in Wastewater Treatment, Reuse and Valorization. I especially thank Sandip University and Society for Green Innovation to invite me to deliver the lecture. So I'll be talking about the digitalization in wastewater treatment. What are the new current technologies are being used in wastewater treatment processes, so which can easy the process and which can enhance the monitoring at a time. So shall I share my screen?
Yes, sir, yes.
Is my screen is visible now? Hello.
Yes, sir, yes, it is visible.
Okay. So good morning, one and all. So the topic of presentation is digitalization in wastewater management. So first of all, I would like to talk about the what is the wastewater. So wastewater may be any water which may have the unwanted content in it. So it may be generated from various sources. It may be domestic, industrial, or stormwater. So first of all, what is domestic wastewater? The wastewater or water which is after use being discharged from the residential, shops, houses, offices, school, etc. So generally it contains the water or wastewater coming from toilets, sinks and bathrooms after washing, bathing, kitchen and all. So wastewater from domestic can be divided in two sectors. First is grey water, another is black water. So black water is the water which is coming after use from the toilets, and grey water which is coming or released from after use from washing, bathing, and kitchens. But as of now, in India also, or in even in some developed countries also, we do not have separate collection system for grey water and black water. So if you can see in India, in India, some places even we do not have separate collection for storm runoff also. In some cities or some rural areas or some urban areas, storm water also get contaminated or mixed with black water or grey water. So in India, we have only one sewer line which contains black water and grey water. When we mix both, we named as a sewage wastewater. So if I talk about the industrial wastewater is basically generated from several industries, and the quantity and quality of the wastewater which is being generated from industry depend upon type of industry, type of process the industry is using. The quantity also depend on the type of process which is being used by industry. And the third one is stormwater. Stormwater also can be considered as a wastewater, because what is stormwater first? Stormwater is the water which is coming when rain comes. The overflow on the surface of the ground is called stormwater, or that is called runoff. So when water flows on the ground, it may contain lot of impurities, or it may carry the litterings on the surface. The water which is coming from agriculture fields, it may contain several type of pollutant like pesticide, uh, and all these, and at the same time the water is flowing on the ground, it may contains lot of clay particles, dirt and all. So in in one sense we can say storm water also can be considered as a wastewater if it contains lot of impurities which is already on the ground. So we can categorize the wastewater in three category. So if we talk about the application, why digitalization is useful in the wastewater management. Digitalization means using online instruments, or online, or using instruments to monitor the online parameters or in the flowing parameters. So digital instruments can be used at several places. So the first is collection. To monitor the quantity of wastewater, we can use flow meters. At the same time, we can check some quality parameters as well. So why quality parameter and flow is important? Because if suppose any industry which has their own treatment plant, then flow is not required. But for CETP, common effluent treatment plant, CETP is a term which can be used to define a process or a treatment unit which is useful to treat the wastewater which is being generated from several industries. So when industries send the wastewater to the CTP plant, the CTP plant has to charge on the industry on the basis of quality and quantity of the wastewater. So for that they have to need to set up some technique by which they can identify the quantity and quality of the wastewater being discharged from the particular industry. So nowadays we have some online monitoring system by which we can place the instrument in the pipe itself. So it will give some major parameters like flow and major polluting parameters. So on the basis of that we can charge on the industry. Then treatment sector. In treatment sector, there are several type of digital instruments are being used to control the quality of the wastewater which is being treated in the wastewater treatment plant. At the same time, we can save lot of energy when we install such type of instruments into the treatment plant. So these instruments can control the process. At the same time, it can give the information on the quality of several polluting parameters. So on the basis of data given or readings provided by the instrument, we can control the uh, uh, operating parameters into the wastewater treatment plant. And the third sector is disposal. As you know, in air sector, most of the industry is uh, forced to display their quality parameter on the gate of their industry. So similar to in wastewater also, in coming days some legislation will are about to come to display the water quality parameters on the gate of the industry. So what is effluent quality? After treatment of the wastewater in the industry or in treatment plant, the quality of the effluent must be checked. because it should be in the permissible limits. So till now, what we are doing?
Excuse me, sir. Excuse me,
Yes,
sir.
please.
Your slides are not moving.
So I'm still on second slide. Application of digitalization. Slide number
Okay,
3 is
okay.
visible now.
Sorry,
Slide 3
sir.
is visible.
No, sir. We are just able to view only slide number 1.
Okay. So let me share it again. Your slides visible now?
Yes, sir. Yes, sir.
Slide number 4 is visible.
Yes, sir. It is visible.
So I was talking about the application of digitizer at different places. So now I come to the type of contaminants. So in wastewater or in water, we may have several type of contaminants. Like it may be organic matter, pesticides, solids, nutrients, pathogens, inorganic content, color and odor, thermal. So when the temperature is high, that if suppose we are not adding any pollutant into the water, but we increasing the temperature of the water, that also considered as a wastewater. Like thermal industries, which doesn't add any external material into the water, but they only increase the temperature. So if they increase the temperature of water, that also can be considered as a wastewater. So if you talk about the general parameters like organic matter, pesticide, we are not bound to identify individual organic matter or individual pesticide content. So what we do in wastewater, certain parameters has been defined to identify inorganic or pesticide or other organic matters into the wastewater. So what are these parameters? So we categorize the parameters in three categories. So first is physical parameters, second one is chemical parameter, then biological parameter. In physical parameter, what are the parameters that we measure? That may be solids, temperature, odor also can be considered as a physical parameter. In chemical parameters, dissolved oxygen. So what is the concentration of oxygen is there in the water or in the wastewater? If DO is deplete, if the oxygen concentration is low, we can say water is not suitable for human use or for other purposes. Chemical oxygen demand is like a chemical parameter which defined a cumulative role. Like if any organic material are present, we are not bound to identify the individual component, but as a whole we can calculate the concentration of organic pollutant into the wastewater. Those basically chemical oxygen demand is measured in the terms of oxygen requirement to degrade the organic matter. Similarly, biochemical oxygen demand is we call BOD. BOD is a parameter which identify the concentration of organic matter present into the wastewater, but which is suitable for biological treatment or for consumption of microbe. So there's major difference in COD and BOD is in chemical oxygen demand and biological oxygen demand. Biochemical oxygen demand is chemical oxygen demand gives us the total oxygen requirement to degrade the organics present in the wastewater. At the same time, biochemical oxygen demand represents the oxygen requirement by the microbes to degrade the organic matter. At the same time, nutrients may be nitrogen and phosphorus content. And in biological parameters, we measure generally total coliform and fecal coliform, which considers a pathogenic substances for human applications. So these are the major parameters or commonly used parameters in the wastewater treatment plant to be measured by the digital instruments. So first one is flow. We can measure the flow. Level and pressure can be measured in the pipes using some digital instruments. Temperatures, obvious, we can use some temperature meter to measure. pH meter also available and can be monitor the parameters online. Conductivity, oxygen, dissolved oxygen, for that we use DO meters in the for online monitoring. turbidity can be measured online. Sludge concentration is basically parameter which is useful for biological treatment systems. Sludge blanket level is also a parameter which is used for anaerobic reactors to check the level of sludge into the reactor, or to calculate the total biomass concentration into the bioreactor. Nutrients is also again can be measured nowadays online also, or because some probe kind of thing or some online devices are coming up which can give the instant concentration of nitrogen or phosphorus into the waste streams. Organic matter definitely can be measured by in terms of COD, as well as nowadays for BOD, like the organic substances suitable for microbial degradation also can be measured online nowadays. Gas volume, when we go for anaerobic treatment process, what is the total gas quantity is formed or biogas is formed into the reactor can be measured online. So uh, if we see the traditional methods to identify these parameters, suppose if we go for physical parameters, we need instruments, at the same time we need lab, and it requires more time. If I say, if I have to monitor the total suspended solids into the wastewater, or total dissolved solid into the wastewater, I have to keep the sample for at least 24 hours to measure the solid concentration. But if we use some digital meters, we can instantly or online can be monitored, or we can get the result at moment. So if you go for chemical also, like if I talk about the chemical oxygen demand or biochemical oxygen demand, for chemical oxygen demand we have to wait for 1 day to get the result, or for biochemical oxygen demand we have to wait for at least 3 to 5 days to get the result of BOD in if we go for lab testing. So these are the some limitations while going for the conventional treatment processes. Or for biological, similarly, we need skilled personnel, instrumentation facility. At the same time, lot of time is required to get the result. So to overcome all these things, nowadays for almost all the parameters, instruments are available which can be fit into the treatment plant or in the pipeline or in the inlets chamber, so that we can get the result instantly, or we can at the same time we can improve the efficiency, or we can check the performance of the treatment plant, or we can save the lot of energy into the treatment plants. So what type of treatment plants, treatment wastewater treatment processes are there in the market? So it can be categorized again three category: physical treatment, chemical treatment, and biological treatment. In physical treatment, only retention time is given, like to settle the large objects into the wastewater effluent. So for that we use sedimentation process, in which we give the time to settle down the large particles at the bottom of the uh, sedimentation tank. So for that we need to control the flow, or in other sense we can say we have to give retention time into the sedimentation tank. So retention time can be calculated based on the design, but flow we have to maintain. So for to maintain the flow, we can use some digital meters which will control the flow and maintain the retention time into the sedimentation tank. If we maintain the retention time, the efficiency of particle removal will be enhanced. In chemical, we add some chemicals to precipitate out the pollutants. So the dose of the chemical, at the same time the pollutant concentration can be measured, and we can control online into the treatment plant. For biological, we use certain type of microbes into the plant which will consume the organic matter and produce CO2 and S2. At the same time, it may, if it is anaerobic, we can produce CO2 plus CH4 methane, that is called biogas in the plant. So in biological plant, we have to monitor several parameters, like some biological systems may be sensitive to pH. So we have to monitor the pH. At the same time, we have to control the pH. Some in aerobic systems, microbes are sensitive to oxygen, dissolved oxygen, so we have to maintain the oxygen concentration into the treatment plant. So accordingly we can fit required instruments to control required parameters into the plant to improve the efficiency. So if I go one by one, if we if we discuss about the physicochemical treatment processes, we can monitor the addition of chemicals, we can control the mixing of the chemicals. At the same time, we can control the separation of sludge into the settling tank using some IoTs. At the last, we can monitor the effluent quality also by placing some online monitoring systems into the treatment plant. So this is a schematic diagram for domestic wastewater treatment, which is majorly used into by the most of the municipalities for sewage treatment, and some of the industry also use this kind of treatment process because it is a biological process. Biological process uh, uh, require more time in compared to chemical processes, but at the same time the cost of treatment is very less. So that's why most of the municipalities and industry opt the biological treatment processes. So biological treatment processes again categorized in three categories. It is that three stages are there. So first is called preliminary treatment, where we remove the particle by using some gravitational force. So in preliminary treatment, we remove the particle size greater than zero point 0.2 mm in size. So accordingly, we can control the flow of the wastewater into the chamber so that sufficient retention time to be given to settle out the particles. In primary settling tank, less than 0.2 mm particles are settled down. So there is a called primary sedimentation tank where we give sufficient retention time to remove the particles which is lesser than 0.2 mm in size. So here we have to give approximately 2 to 4 hours of retention time into the tank. So in 2 to 4 hours, some fine particles also can be settled down at the bottom, and from the bottom we can remove the solid particles and we can send for another treatment. At that same time, supernatant can be sent for secondary treatment, which is nothing, simply aeration system, where we can use some kind of aerobic microbe which will consume the organic matter and convert into CO2 and H2O. In secondary sedimentation tank, we segregate the microbial population from the wastewater and recycle back to the aeration tank to maintain the population into the microbial population to the aeration tank. So whatever is sludge is there, that will again send for sludge digestion or secondary treatment, where we can treat the sludge and dispose for sludge disposal can be like it may be can be used for manure after certain treatment like after composting and all, and whatever the supernatant is there, it will send back to the primary settling tank. So how can we use the IoTs, uh, uh, Internet of Things into wastewater treatment plant to monitor the efficiency of the plant, at the same time to save lot of energy. So in preliminary treatment process, as I suggested, we can control the flow so that sufficient retention time can be given into the settling chambers. Similarly, primary settling tank also, in secondary treatment, where we can use some optical parameters like dissolved oxygen parameter can be used to monitor the oxygen level into the system. If it is an anaerobic treatment, we can check the biogas production into the system, so that at the same time we can control the pH into the system. So, or we can say we can create the suitable environment for the microbe to degrade more and more organic components. After the treatment, we can use IoTs at the disinfection unit also, where we can kill the microbe or kill the pathogens. If we are sending the wastewater for open drains or in rivers or for land application, we have to give uh, tertiary treatment, that is for disinfection, where we kill the microbes from the wastewater. So, as I said, in IoTs can be used in pre-treatment, where we use the IoT or flow control devices to control the flow to give sufficient or required retention time into the chamber, so that required size of the particle can be segregated out from the grid chamber. Similarly, in primary settling tank also, we can monitor the suspended solid concentration into the primary settling tank. If more concentration of uh, suspended solids are getting at the effluent, we have to increase the retention time. So the main use or main advantage of using IoTs in settling tank is immediately we can react or immediately we can change the parameter to increase the efficiency. If you go for physical method or conventional methods, suppose today we collected the sample, next day we'll get the results. So for 24 hours, lot of the fluctuation may be happen, and it is very difficult to control after certain time. So if we use IoTs into the treatment units, we can react to change the parameters to improve the efficiency. So as I said, in secondary treatment, we can implant several type of monitoring devices, like dissolved oxygen can be monitored. If dissolved oxygen is monitored, other parameters simultaneously can be controlled. If DO is high, we can reduce the blower energy to control the DO. If DO is depleting, we can increase the power to give more oxygen into the tank to maintain the oxygen into the aeration tank. At the same time, other parameters like pH, ammonia, nitrate, solids, orthophosphates, and other parameters like concentration of microbial concentration into the tank also can be monitored online, so that we can improve the efficiency, and at the same time we can save lot of energy into the system. So for disinfection unit, there are several type of disinfectant. Like if we are using chlorine, we can monitor the chlorine level, and at the same time we can monitor the chlorine dose into the, or control the chlorine dose into the outlet chamber. If you are giving some other treatment like UV or ozone treatment, we can change the voltage and we can increase or decrease the efficiency of the UV rays and on ozone concentration into the chamber to improve the efficiency. So if we see the current states or current trends, lot of innovation is being going on. So if we see the approach in innovation in sensing approaches, like lot of improved sensors are being developed nowadays, and lot of high-end sensing devices or probes are available into market for various parameters. Lot of research is going on in data processing control, where we are using sophisticated automatic real-time data analysis, so that we can get the real-time data, because after monitoring the data we have to process the data as well to get the required result. As I said, sensing technologies, optical sensor, ion electric sensor, selective electrodes, biosensors are coming up into the market too. That these are the very sensitive and very accurate devices. Research in data analysis and control. Lot of controllers are being developed. Modeling applications are going on, and nowadays we are using machine learning algorithms also to interpret the data and predict the required data. So if I take the real field application of IoTs into the field, so most of the sequencing based reactors, that is called SBR, is basically SBR is a completely automated system. So no manpower or manual monitoring is required. Everything is automated in SBR. So this is called one of the successful story. So SBR is basically developed by CTEC process. CTEC is basically a technology provider which is building the completely automated wastewater treatment plant based on SBR. SBR is basically a sequential process. It is 4 stages are there. First, the aeration starts. In the first stage, aeration is given. It's basically aerobic process. So after 90 minutes of aeration, once the aeration stops, it gives 60 minutes, 30 to 60 minutes settling time, so that whatever the microbial concentration are there, that will settle down at the bottom. Once the microbes settle down at the bottom, decanting start, the removal of treated wastewater. So treated wastewater is decanted from the top, because at the top will get less solid concentration. So decanting happens start from the top and automatically is lowers down. So up to the required level. Once it reaches the required level, automatic cutoff is there. So it's a basically 4-stage process, but happens in a one reactor only. So all 4 stages happens in single reactor. So for that, all parameters are monitored online, like DO. On the basis of DO concentration, diffuser works. The performance of diffuser works on the output of DO parameter. So once apart from the DO parameter, some solid concentration, suspended solid monitoring probes are also available, which monitors the level of the decanter. So up to what level the decanter must go to remove the supernatant. So it's a completely automated process. This is the technique developed by CTEC technology, and it is like basically can be fixed in sequential based reactors. So apart from the SBR, in lot of municipalities, people are using automated devices in actuated this thing biological treatment processes also instead of SBR. So this is what about the application of digitalization in wastewater treatment. So these are the references from I have taken the content to prepare this PPT. Thank you all. Thank you for your patience listening. If any questions, I would be happy to answer.
Thank you, sir, for discussing the various aspects for the digitalization of wastewater. Purnima ma'am, are we having any questions from audience?
Sorry, we don't have a question now.
Sir, just there is one question in my mind. Are the chemical the are the all methods which are discussed, chemicals, either physical or biologicals, are the results are varying with the time?
Sorry.
Uh, just in the previous slides, the various methods are discussed: chemical, physical, and biological methods.
Yes, ma'am. Yes, ma'am.
So suppose if we take the results of fresh samples and if we keep them for 1 week, so are the results are going to be vary according to that, and are this thing going to be uh, affect on the digitalization?
No, actually, digitization basically will give the instant result. So basically, digitization means it's an online monitoring system. So for digitalization, we need not to store the sample. For physical methods, we have to store the sample for long. But in digitalization, it will give instant result. We have to fix the instrument into inline process. So once we fix the instrument in inline process, it will give instant results because lot of data processing techniques are there. So it will give directly the output or required result in form of which we required. So there is no requirement to store the sample or to collect the sample at the from the source. So means basically fixing of the instrument in the plant itself or in the line itself. Hello.
Hello,
Haan ji, ma'am.
sir. There is one more question. Can you please elaborate on the stability in online monitoring of the nanomaterials?
For nanometer, I do not have much knowledge about the nanoparticles or nanomaterials, but yeah, definitely nanomaterials are being used to develop some kind of sensor and some kind of like monitoring devices. But I do not have much idea what kind of nanomaterial is being used in developing the instruments to monitoring the various parameters.
Thank you, sir. Thank you very much for
Thank you,
being with
Dr.
us.
Dr. Patil.
Thank you,
Thank
sir.
you a lot. Thanks a lot for giving me the opportunity to deliver the talk on this platform. Thanks a lot. Thank you, everyone.
Thank you, sir. Now we will going to move to the next session. Over to you, Purnima, madam.
Thank you very much, sir. Thank you, ma'am. Now, I request Dr. Angana Sarkar to deliver the lecture as a speaker of this session. The topic of her lecture is Microbial Dye Degradation, a clean approach dye removal from pharmaceutical wastewater. Again, I request Dr. Leena Patel as the chair of the session. Over to you, madam.
Good morning. I am heartily welcome to our speaker, Dr. Angana Sarkar. Good morning, madam.
Good morning. Am I
Dr.
audible?
Sarkar, yes, ma'am, you are audible.
Okay.
Dr. Sarkar has pursued her graduation in agriculture engineering from Vidhan Chandra Krishi Vidya Vishwavidyalaya, West Bengal, India, followed by the post graduation in biotechnology and biochemical engineering from IIT Kharagpur. Later, she completed her PhD in environmental biotechnology from Indian Institute of Technology, Kharagpur. Subsequently, she joined the National Institute of Technology, Rourkela, in the year of 2015 as an assistant professor in the Department of Biotechnology and Medical Engineering. Her research area is mainly focused on pollutant detection using biosensors, groundwater bioremediation, wastewater, domestic as well as industrial treatment, solid waste management by biorefinery approach to produce environmental waste to value including bioenergy, bioethanol, pigment, biofertilizers, etc. Hydrocarbon and other organic pollutants degradation. She is supervising a number of doctoral dissertations, master theses, and advised many undergraduate students. She has a combined more than 50 publications in various SCI cited journals, book chapters, and peer reviewed conferences. She is also currently editing the two books with the Elsewhere, and she is also serving as a reviewer in a various reputed national and international journals. So once again, I welcome you, ma'am, and I kindly request you to proceed with your talk.
Thank you, ma'am, for giving such a nice introduction about me. So, I would like to share the recorded one first. If it is not working, then I will share another one. Okay. So, let me try with recorded one first. Okay, just. So, is my screen shared? Can you see? Can you see the shared screen?
Yes, sir. Screen is visible, ma'am.
It is visible.
Yeah.
Okay, so I'm going to play first. If it is working, then fine.
Okay, ma'am.
Good morning, everyone. Myself, Dr. Ang.
So can you see
Now,
here?
coming to my topic.
Yes, yes, it is working,
Okay,
ma'am.
okay. So from the beginning again, I am playing. Okay.
Good morning, everyone. Myself, Dr. Angana Sarkar. Presently, I am working as Assistant Professor in the Department of Biotechnology and Medical Engineering, NIT Rourkela. Today, I will share my research topic entitled Microbial Dye Degradation, a clean approach of dye removal from pharmaceutical wastewater in the International Conference on Current Trends in Waste Treatment, Reuse and Valorization. This conference is jointly organized by School of Science, Sandip University and Society for Green Environment. I am thankful to the organizer for inviting me to share my research in this platform. Now, coming to my topic, I think all of you have already heard about the terminology emerging pollutants. So, what are they? These emerging pollutants are mostly synthetic or sometimes naturally occurring chemicals or any microorganisms. Those are detected or monitored in the recent past. So you can call them as new arrival in the pollutant list. But they are equally or sometimes more harmful or hazardous to the environment as well as the human beings than the common contaminants. They have potential to enter in the environment and cause adverse effect in terms of ecological as well as the human health effects. So this is the time or high time to take care of these emerging pollutants. So these are the major actually distributed pollutants, emerging pollutants. So the pesticide is the dominated by 57%, followed by pharmaceuticals with 17%, surfactants with 15%, and personal care products with 7%. This is the detailed classification of the emerging pollutants. Whatever the compounds are there, they actually attribute toxicity towards soil, water, or air system, or they can be uptake by animal, plant, or microorganisms, and ultimately they will enter in the environmental system and affect the human health. Today I will discuss about only pharmaceutical waste among these all emerging pollutants. And now source of these pharmaceutical wastes are the manufacturing industries and the consumers. And consumers in terms of household and hospitals. So whatever the source may be, these ultimately enter into the water system, either in the surface water or groundwater system. And this water will be either consumed by animal and human beings or will be used in the agricultural land for irrigation purpose, and which ultimately distribute the toxicity among environment as well as human being. The adverse effect of these pharmaceutical compounds in the human being is that they can cause different malfunction in human health, and this includes organ dysfunction, endocrine disruption, as well as cancer if it is accumulated in more amount in the human body. Pharmaceutical wastes contain different components including antibiotics, steroid hormones, antidepressants, preservatives, non-steroidal anti-inflammatory drugs or NSAIDs, and colorants or dye. These compositions may vary based on the manufacturing of different drugs. So different pharmaceutical industrial waste is containing different components based on their drug production. Now, in this post-COVID era, you can easily imagine that how much amount of drugs already we have consumed. So they have already entered in our environmental system. So that is the prime thrust of the research area now. So to remove these pharmaceutical pollutants, there are different strategies, chemical, physical, mechanical, but the bioremediation strategy is the most useful one since it is not having any byproduct formation. So use of microorganism will be more beneficial in the degradation of these different pharmaceutical components in the water or wastewater system. But the pharmaceutical waste is a mixture of different components, so it is a complex in nature and that's why there are different challenges to get the proper strategy for this bioremediation. So we have targeted all components, whatever I have discussed in previous slide, but today I will focus only the dye or colorant. For our research purpose, we have collected wastewater from the Cadila Pharmaceutical Limited, which is situated in Ahmedabad, Gujarat, and we have collected different wastewater from the pharmaceutical industry. And in this industry, actually, drug is processed in 5 steps. In first step, it is the active component synthesis step. Second one is the granulation and blending. Third one is the compression. Fourth one is the coating, and final one is the packaging. And the wastewater is generated in the granulation and blending and coating process. And the wastewater generated in the coating process is containing the dye. Coating dyes are maybe of different types, including indigo, carmine, amaranth, sunset yellow, quinoline yellow, tartrazine. So we have targeted these 5 dye for degradation study by microbial activity. So this is the workflow diagram for dye degradation study in our lab. So first we have collected the sample and characterized the sample thoroughly. Then we have set the enrichment study to get the potential dye degrading microorganisms. Then we have conducted the virulence study to get the non-pathogenic organism for future application. Since we are working with environmental sample, so the microorganisms are unknown to us, so we need to check their pathogenicity. For that, virulence property checking is very essential when you are working with environmental sample. Then non-pathogenic dye-degrading microorganisms have been selected and their individual dye degradation ability was tested. After the individual dye degradation study, we have conducted the formulation of consortium, and we have constructed different consortia, and among those consortia, based on the matrix course matrix, we have selected the best consortium for the dye degradation, and the members of this best consortium has been again characterized thoroughly by using the biochemical characterization and their molecular identification through the 16S RNA gene sequencing. For virulence study, we have conducted a hemoglobin utilization test, hemolysin production, protease production, lipase production, lecithinase production, cigatoxin production, DNA assay, and protein A layer detection through Kumasi brilliant blue assay. So you can see here that clear zone is the positive indication for hemoglobin assay, hemolysin assay, protease assay, lipase production assay, and DNA assay. And for lecithinase production, you can get precipitation, and colorless colony you can obtain for cigatoxin production positive assay. And for brilliant blue assay, you can get blue colony as positive result. So these are the different plates for this assay we have conducted for all the dye degrading stains. Here you can see the table for the virulence assay for all these dye degrading stains. So total 24 stains have been selected for superior dye degradation, and then all these assay has been conducted for checking their virulence property. And here you can see most of them are actually negative to this virulence. So green is indicating negative one, and red triangle is indicating the positive response to the assay. So finally, actually, these stains, 8 stains have been selected where you can see there is no positive assay result. So we have constructed consortia using these non-pathogenic stains only for our future work. Microbial degradation of individual dye has been monitored by using the spectral scan, and you can see here the wavelength range for detecting different dye. You can see here the dye degradation pattern by different bacterial stains. So for each bacterial stain, all 5 dyes have been tested and degradation has been actually calculated. And based on these dye degradation pattern, we have formed one score matrix. And based on that score matrix, again we have formulated the consortia. This is the score matrix based on the degradation of dye by individual strain. Here you can see these are the strains and these are the different dyes. And here also you can see that different color gradation is there. Green color is indicating the superior one. Here mark number is also given in each column. So you can see that green color showing the maximum degradation score and red color is the lowest degradation. Based on the degradation score, we have actually received the cumulative score here, and based on that we have given the rank. So rank 1 is the superior degrading bacteria for all dye. Based on the score matrix obtained for individual bacterium for different all 5 dyes, finally we have constructed 5 different consortia named C1, C2, C3, C4 and C5. In this consortia, we have actually selected individual based for each dye, top 2 base score, top score and bottom score, top scores and medium scores and bottom scores. These 5 combinations we have taken, and again we have constructed the consortia. And here you can see in one consortia 4 or 5 members are there. Like in C1 consortia, you can get the stain number 7, 10, 11, 18. They are all having the superior dye degrading ability. Then in C2, in this way, we have selected the 6 members. In C3, we have selected 6 members. And C4, we have selected 6 members. And 5 also, we have 6 members. Only in C4, we are having 4 members. So after construction of the potential consortia, we have tested their dye degradation ability, and this graph is showing the dye degradation by each consortium for each different dyes and also overall degradation we have studied. And here you can see the maximum dye degradation was monitored in the GC1 consortium, and this is the experimental setup where you can see almost 96 or 97% degradation has been achieved by this GC1 consortium. We have also constructed the score matrix for each consortia, and here you can see that score matrix or cumulative score for GC1 is the lowest. That means it indicates the superior degradation ability. So based on the potential of the dye degradation, the GC1 consortium has been selected for further work, and the members of this consortium has been characterized properly. And already I have mentioned that this consortium is containing four strains: DY7, DY10, DY11, and DY18. And these all strains are also non-pathogenic in nature, which has been shown in virulence property assay, and their detailed carbon utilization property has been tested, and you can see this is the profile of carbohydrate utilization by these strains. And these are the different biochemical characterizations, including gram staining, indole production, methyl rate, Voges prosecute, and cited utilization. Antibiotic resistance property has been checked for all the members for the selected consortium, and this is very essential to control the overgrowth of the microorganism if required. So you can see here the most of the strains are susceptible towards the antibiotics tested. Only few are showing the resistance. After the thorough biochemical characterization of the selected strains in the consortium, finally the strains were identified through the 16th RNA gene sequencing. So DNA has extracted from individual strain. After that, the 16th RNA gene has been amplified through the PCR reaction, and this is the gel image for the PCR amplification, which is the size is the 1.5 kb for 16th RNA gene, and then the product has been cloned and sent for sequencing for Sanger sequencing. Then the sequence has been blast in the NCBI, and homology sequences have been downloaded and constructed the phylogenetic tree using the Mega software. Here, this is the phylogenetic tree for all four strains, and they showed their similarity towards the Klebsiella species, though they also the genus Klebsiella, but species may be different because this is the partial sequence of 16th RNA gene. So at species level, we can't comment in this phylogenetic tree, but after complete sequence of 16th RNA gene, we can get the species level identification also. Now coming to the conclusion, so total 24 strains has been identified for their degradation ability. Among them, 90 were selected based on virulence property assay, and these 19 again used for construction of the bacterial consortium, and 5 total consortium has been obtained. Among them, the consortium C1 showed the maximum degradation with 96.65%, which is really promising. And the members of this consortium has been identified as the member of Klebsiella species. The species level identification is still remaining, but this consortia is having potential application in the degradation of oxides, and this work has been published in the ESPR journal in the title Construction of Bacterial Consortium for Efficient Degradation of Mixed Pharmaceutical Dyes. So you can read this article for more detail. Now I would like to acknowledge my institute, National Institute of Technology, Rourkela, for providing me the infrastructure for conducting this research. The funding agency, ACRB, and this work is a piece of the imprint two projects. And obviously, I would like to acknowledge Cadila Pharmaceuticals Limited for providing us the sample for the study. And finally, I am very lucky to have my co-workers Kasturi and Devotri who are working in this area. Thank you very much for your kind presence and listening my talk. I would like to thank again the organizing committee members who have given me the opportunity to share my research work in front of you so that in future again we can meet and collaborate for bigger prospect of this research. So anytime you can join with me. My laboratory name is EMGL. So you can easily contact me and we can work together in future for different aspects. Thank you for your kind attention.
Thank you, madam, for providing the detailed information about the microbial degradation by the various strains of a bacteria.
If there is any question, I will be happy to answer.
Purnima, madam, is there any question from audience?
Yes, ma'am, we have. Ma'am, you can see the question. How to manage the concentration of pollutants with respect to consume potential.
So for this, actually, the initial concentration we can't control. This is actually based on pharmaceutical industry, what they are generating. Okay, we have to take that waste and then based on the concentration, what is available. So we can get the average concentration of each batch for any industry. Then based on that concentration, we can construct the consortium. Okay, so if we target higher concentration, so we will select the strains accordingly, and those strains in the consortium will act for those particular high level of concentration of the pollutants. Anything else, madam?
Thank you, madam, for your valuable time.
Okay, thank you again for inviting me to share my research. Thank you.
Thank you, madam, for sharing your knowledge with Good morning, ladies and gentlemen. It's a great pleasure for me to introduce our speaker today, Dr. Sukhdev Pal, who is going to talk to us about the inorganic nanostructure for multifunctional applications in water treatment. Good morning, sir. I welcome you for the International Conference on Current Trends in Waste Treatment, Reuse and Valorization. Dr. Pal is currently working as Principal Scientist in Wastewater Technology Division of CSIR Navy Nagpur. And he is leading the NABL Accreditation Technology Division Technology Wastewater Laboratory of Institute as a technical manager. He is also serving as an associate professor of chemical sciences in academic of scientific and innovative research. He obtained his bachelor's and master's degree in chemistry from the University of Kalyani. He obtained his PhD in the area of nanotechnology from the College of Pharmacy, Seoul National University, South Korea. He performed his postdoctoral research at Applied Pharmaceutical Sciences Research Division at Seoul National University. He worked in quite a few industrial and academic research institutes, both in India as well as in abroad. He is the recipient of Excellent Performance Award in Research by the Hindustan Unilever Limited Brain Korea 21 Scholarship for the graduate students. Excellent Research Award by BK21. BK21 Postdoctoral Fellowship, Early Career Fellowship from Wellcome Trust DBT. He has published many scientific articles in leading peer reviewed high impact journals of international repute. And he has contributed to more than 20 book chapters. He has presented in more than 60 international conferences and has delivered many invited talks. He also authored 30 plus technical reports. He has 50 granted patents to his credit as an inventor, which includes US patents, and has more than 30 national and international patents application. He has been serving the student, he has supervising the students for their PhD, MTech, MSc, BTech and B dissertation. So once again, a very warm welcome to you, sir. Over to you, sir.
Yeah, yeah, thank you. It was a really long introduction, and I didn't expect that you will read out the whole biography. Anyway, thank you so much, and I also thank the organizers for inviting me to deliver a talk uh, in your international conference. And I also followed this conference yesterday, though I joined a bit late because I didn't have the link. But it was a good deliberations, and it was really nice to listen to those deliberations from students and also the faculties. Uh, is my screen visible? Hello, hello,
No,
hello.
sir. No, sir. Your screen is not visible.
Okay, but I'm audible, right? Yeah.
Yes, sir. You are audible.
Is it visible now?
Yes, sir. It is visible now.
Okay. So today I'm going to talk about the inorganic nanostructures for their multifunctional applications in water treatment. But when I started this kind of research, it was not water treatment at the beginning. Mostly, I worked on medicinal front for burn wound care and related work. Right, mostly my research was focused on burn wound care for critical patients. But then after joining NIRI, I shifted that research focus to water treatment. So usually, when I talk about this topic, I cover both the biomedical aspect as well as uh, the environmental aspect. But today, because of the time constraint, I will focus mostly on the environmental aspect. That again been narrowed down to water treatment. So, as we know all what nanoparticle is, because the as the title suggests, the nano should be very small in size. But smallness in itself is not the goal that we would like to achieve. Now, nanoparticles of 10 raised to minus 9 meter dimension, uh, they could be of inorganic and organic nature. We are most interested in inorganic nanoparticles, and inorganic nanoparticles essentially is made up of metallic nanoparticles, where usually the metal is stabilized in a zero valent state, but there are nanoparticles where the metal is not in the zero valent state, and they could exist as their oxides or metal complexes. They have been extensively studied for their environmental applications, but the problem is they often lose their nanostructure and the properties that come out of because of their nanostructure in when they are put in a critical condition or environmental matrices, and that's why they are very hard to handle in aqueous solution. And they also show very pollutant specific applications, because one nanoparticle or one kind of nanoparticle will serve only one purpose. Like if you see here, some of the possible applications of nanoparticles is shown in this cartoon. It could either act as a photocatalyst, where they will degrade organic compounds in our pathogens, or they will oxidize organic organo chlorines like this, or they will have adsorption, or they can act as a catalyst in a photofenton or photofenton reactions. When we want to make um, a nanoparticle or a nanocomposite or nanostructure multifunctional, means only one particle will serve many purposes, then like you can think of a mobile phone. Like now, when we have mobile phone is 90s, you said that was used mostly for talking over the phone. The main purpose of mobile phone is still to communicate between two distant locations, but it has got now several other applications, like it can be used as a camera, it can be used as a scanner, it can be used to send text messages in real time. Like that, it has become multifunctional nowadays. Even you can track the positions, GPS locations, and so many other applications people are aware of. So when we want to make some nano particle multifunctional, usually we have to incorporate multi-components. So this is a transition from a single component system to a multi-component system, where the components individually may retain their either the properties, or they could, because of the combination, some new properties could emerge, which is distinctly different and advantageous over the constituent components. Like bimetallic nanoparticles or multimetallic nanoparticles are this very common in this multi-component system and functional system. They could be of different structures: core shell structure, heterostructure, intermetallic structures, and
Excuse me, sir.
single
Your
composite.
slides are not moving.
Yeah, I am still on the first slide. Single composite can remove different classes of pollutants simultaneously. That's the function. Now, if you see this, can you see the next slide? Is it visible? Excuse me.
Hello, sir.
Hello.
Your
Yeah,
slides
madam.
are not moving.
Now, can you see now the binding sites can be created like this slide? Is it visible now?
No, sir. We are visualizing only the slide number one. Yes, sir. Now
Can
it
you
is
see?
visible, sir. Yes,
Okay,
sir.
if I
Yes.
make, yeah, if I make it full screen, then it's not visible. Okay, I'll just then present in this way.
Yes, sir. Sir, you can put it on slideshow.
I put it on slideshow mode. This is now in slideshow mode. Can you see the slides moving now?
Uh, sir, now we are able to see the slide number one only.
I'm on slide number 3 now. Binding sites can be created.
But sir, we are not able to see the slide number 3.
Okay, let me reshare this. Okay, there's a limitation of the file size. Can you see now?
No, sir.
You can't see my slides, but it's showing I'm sharing my window.
Yes, sir. Yes, sir. Yes, sir.
Okay. Now third slide is it visible? This slide binding sites can be created.
Yes, sir. It is visible now.
Okay, so the most popular inorganic nanoparticle or nanostructure is probably the graphene, which has been well researched over the last 2 decades, ever since it was discovered in 2006. So binding sites can be, means graphene has been modified by so many ways to create different applications, mostly for their multifunctional applications like adsorption of heavy metals and adsorption of organic pollutants. You can see some of the hydrolysis structures, and this was published in ACS Applied Material Interface in 2013. Then we can have the next most popular nanostructure that comes out from iron oxides. Different iron oxides can be synthesized, and people have tried to vary their morphology with different shapes and sizes. Here you can see the urchin like or the coral shaped or like flower like structure of alpha FeOH. These are hollow sphere. Inside it's hollow. It has superior capability for water treatment, like as I can you can see on the I don't know, this pointer is missing. On the left hand side, there you can see the removal of color, then adsorption of heavy metal, and then there is adsorption of lead and arsenic like that. And they have very high surface area compared to other nanoparticles, and then their adsorption capacities they have been calculated. I'm not going into the details of those statistics. Next is another way of synthesizing such nanoparticles. If you can see here in the there is a hollow structure where we first loaded the iron nitride, and then it was subsequently subjected to in situ hydrolysis, where we have generated iron hydroxides, and then these hydroxides can be directly subjected to pyrolysis at higher temperature, or even after loading nitrate of iron nitrate, they can also be pyrolyzed directly. And what happens, we get the iron oxides in these pores, and this can be utilized for capture of arsenic. This is the old schematics, and some results are shown here for adsorption of arsenic 3, that is the most toxic form of arsenic, and also arsenic 5. Another bimetallic nanostructure that is of great importance, and there are a lot of literature available. That is iron and silver nanoparticles. Of course, there is other iron, gold, and iron, nickel. This kind of bimetallics are also available, and they also work as a catalyst. But retaining or protecting their structure is a bit difficult, especially iron, nickel, iron, palladium, iron, platinum. These kind of catalysts have been utilized for degradation of persistent organic pollutants, or like halogenated organic compounds. But if we can generate this iron silver bimetallic nanoparticle, it will also have a magnetic behavior, and they have been utilized like certain different applications for like antimicrobial treatment and phosphorus removal, because as you know, for wastewater or treatment, especially for sewage, um, remediation of nutrients like nitrogen and phosphorus, they are really challenging. So this type of nanoparticles may help in remediation of phosphorus. And the stability is a concern. Stability in air due to passivation of NZVI surface. What is NZVI? Nanovalent, nano-sized zero valent iron. So what is passivation? Passivation means the formation of oxide or hydroxides on the surface of the iron. That could make the iron surface more passive, and they can, or due to passivation, the reactivity of such nanoparticles can get reduced over the time. So, why people try to make this magnet responsive nanocomposites or inorganic structures? That's because if you see the cartoon on the left hand side on the screen, where a magnet is used and some pollutants are going towards that magnet, it's a pictorial depiction of the idea. So what people did, they took silica micro rods or silica nanosphere, which are usually porous structures, and they were stabilized as a stabilizer, and they rendered magnetic properties inside those porous silica structures by loading it with iron nanoparticles, and they can be used for like separation of oil. And usually, if you see the most of the nanoparticle research, either they are used for some dye degradation or some other, or say antibacterial efficacy. But here, this is a unique application like removal of oil. So that's very interesting. At the same time, it can remove dyes. It can remove a bunch of heavy metals. It is not very particular for a specific heavy metals. It can remove chromium, lead, zinc, copper, and cobalt. Similarly, we make this and publish this paper last year, in the mid of last year. You can see it's a photo-induced synthesis of coral-like hierarchical iron silver bimetallic multifunctional nanostructure. This was published in Chemistry of Materials in ACS. What we did, usually if you see in literature, for synthesis of these nanoparticles, either one of the constituent has to be in nanoform, it has to be pre-synthesized and they are mixed together to make the composite, or you need some particles to, external stimulating agent or external catalyst to reduce these the other form, or you need some surfactants or some special solvents other than water to stabilize these final bimetallic products. So what we did, we didn't use any external chemicals other than the precursor of silver and iron. We have taken silver 1 and iron 2, and we didn't add anything else other than water. The water was the only solvent used, and we subjected it to light condition. Here if you see, this is the condition in presence of when there is no light, there is no reaction. This mixture contains both iron and silver, and if you expose it to light, usually it's very good under UV light, but you can do it even under solar light, because solar light has a 20 to 30% of UV radiation. So you can get, we got this kind of coral-like structure within 5 minutes. So it's a rapid synthesis of iron and silver, a bimetallic product. Of course, here the metal iron is not in the zero valent state. It's in a +2 and +3 state that I will show you in the subsequent slides. And here you see, when there is only Ag, there is no reaction. Even in the light, no reaction. When there is iron Fe2 plus, there is no change in the dark. That means Fe2 plus is pretty stable in dark. And but if you expose it to light, there will be slight oxidation of iron 2 to iron 3, and we can get a yellow tinge color over say 24 hours. But only condition in this case is that iron has to be in the millimolar range, not in a very high concentration like submillimolar range. And if we go above the millimolar or the range, then what will happen? Immediately there will be precipitation of iron oxides or hydroxides, and we'll lose the nanostructure. Instead of, we'll get a bulk structure. So this is how we control the shape of the iron silver bimetallic, by simply changing the concentration of iron. If you see, when we decrease the concentration of iron, this is how the structure evolved. This is a bulk structure. Then you can see slight generation of flowery structures, and gradually we ended up with this flowery structure or coral-like structures. These are some of the characterization techniques that we used. The one is XRD, powder XRD, to identify the peaks of the corresponding elements, and then this is XPS. It gives us the absolute evidence for the presence of silver zero or silver in the zero valence state. And here is the XPS spectra of iron that shows the presence of both iron Fe2 plus and Fe3 plus in the matrix. So here we can say that silver is stabilized, or nano silver in zero valence state is stabilized in ferrosulfuric oxide structure without adding any external agents, as you can see here. And this is the energy dispersive X-ray analysis for this. These are more characterization, what we did for surface characterization of the particles that we generated. I'm skipping this. This is just elemental mapping of iron and silver in the composite. Here you can see the silver is nicely impregnated inside the hydroxide structure, ferrosulfuric structure. So this is the mechanism what we proposed. It's light-induced synthesis without any without using any external or extramural chemicals. There are 6 stages that we envisage that might have been taken place during the synthesis of this. First one is autocatalytic photooxidation of iron 2 to iron 3, and then photoactive Fe3 was generated, which again reduced back to Fe2 plus, and another part has been gone here, and during this process Ag plus is reduced to Ag0. So this is the mechanism that we proposed, and if you see here, Fe2 is going to Fe3 and it is coming back to Fe3 plus. So this kind of mechanism or this property is called the photo oscillation. So like a pendulum, it is going here and coming back to the original position. And because it is happening in presence of light, if you stop the light, it won't happen. This will be broken. So we call it a photo-induced oscillation or photo oscillation. And this iron chemistry is pretty known in the cloud. If you see in the cloud, where in the air droplets or water droplets, there are very minute quantities of iron present at sub-millimolar level. This kind of photo oxidations is happening every time in the sky, inside the cloud droplets. Now we showed some application removal of arsenite 3. The thumb rule is, if some adsorbent works for arsenic 3, it will work for arsenic 5. But reverse is not always true. And then you can see we have shown some antibacterial efficacy of this material. There is a comparison of different existing material and our material, where it stands. And these are some of the experimental data, or rather that proves our mechanisms or their mechanism of actions against different pollutants. You can see here that it has got very high positive zeta potential that actually help them to bind with bacteria and to kill them. And there are different factors that can affect the arsenite. We studied one by one. So wonderful thing is that using this material, we were able to achieve the WHO specified drinking water guideline for arsenic 3, or arsenic rather, from a 12 ppm concentration. So if arsenic is there in 12 ppm in the initial water, we can reduce it to the WHO guideline level, below the WHO guideline level. Also, it showed tremendous efficacy for selective adsorption of say lead. You can see here some of the kinetics and distribution coefficient. Distribution coefficients are pretty high and they are excellent. They showed excellent specificity for removal of lead and other. Our next, this is another material that we synthesized last year and reported in a journal. This is MOS2, or it's called a dichalcogenides, molybdenum dichalcogenides. It's a layered structure, like it's an analogous of graphene. What people do, if we increase the spacing between or the interlayered spacing between these layers, its property can be tuned. So you can see here wide and defect-rich nanostructures here, where the distance between these been increased, and these yellow dots are sulfide or sulfur atoms. So if these are exposed, they can be utilized for adsorption of different materials more efficiently. So what we try to do, we make defect-rich MOS2 first, and then we made layered double hydroxides. Again, it's a layered material, but it's not photoactive as such. Like silver, if you see magnesium, aluminum, layered double hydroxides, they are more like clean structures. But if you change the constituents, they may show you photochemical activity, but otherwise, as such, they are not photoactive. So what we did, this is a photoactive adsorbent with positive charge. This is a another layered structure with negative charge, and we put this was the idea. So one electrical double layer is there. We then intercalated another semiconductor, which is probably very known, TiO2. But TiO2 here, it's active only in the UV range. We wanted to use the visible range of the light. So this is the idea. One layer double hydroxide, it will adsorb because of the TiO2. The adsorb molecule will get degraded, and this will be self-regenerated and it can be reused. But we didn't want this TiO2 only there to, because we have to use constantly need a source of UV light for this purpose. So that will add to the cost. Can we utilize the solar spectrum of this? So these are different structures. You can see here, it is published in Langmuir Advanced Material, the detailed chemistry you can see here. But what we did again, we had taken first defect rich MOS2. We synthesized this one, and then we synthesized LDH and intercalated with TiO2, and then allowed them to self assemble in a reactor. And what we have generated, we got a product where we have both this LDH, we have MOS2 and intercalated TiO2 in between. So this is the reaction scheme. First hydrothermal synthesis of MgL LDH, then intercalation of TiO2, the synthesis of defect-rich MOS2, and then we exfoliated it to increase the or delaminate the layers, and then allowed them to self-assemble. These are some of the characterization. These despacing shows how the despacing got increased because of the delamination, and during synthesis we used thousands of layers. And these are the typical hexagonal structure of LDH, and these dots, I don't know whether you can see my cursor here, but I cannot utilize the laser here. But if you see, these are the hexagonal structure on the right hand side, left hand corner, and these black dots are TiO2 nanoparticles, and this is the composite. Now these are more characterization of MOS2, and we try to do SID pattern to know the different crystallized structures that exist here. And again, there is a more characterization data, and this is the characterization of TiO2 nanoparticle with different phases existing in the mostly anatase and rutile. And then XPS spectra, you see the hell lot of data is there, and it's difficult to explain everything here in this talk. But we did this kind of characterization, and finally this is the band gap that shows that our if you see MOS2 has a very low band gap to 1.91, and it is a photoactive material in the visible region. If you see only TiO2, this is MgL LEH. It has its band gap is 5.1, EV, electron volt. It's not photoactive at all. And this is titanium incorporated LDH 3.61, which is nearly about similar to titanium. That means it is active in the UV range. And here is the final composite, the 2.92 here, and that has got both MOS2, titanium, and LDH. It is 2.92. That means it is now active in the visible region. So this is more of the adsorption spectra of these materials, solid state adsorption spectra. And we utilize the same material to degrade both the dyes, both rhodamine dye and Congo red. One is cationic dye, one is anionic dye. Rhodamine is cationic dye, and Congo red is anionic dye. So same material is utilized for degradation of both the dyes, and then these are the reusability test. We tested it up to 5 cycles. That shows their self rejuvenating ability when uh, after adsorption it was exposed to light, the adsorption sites get rejuvenated, and you can see it for both the dyes. And this is the mechanism we proposed because of this heterojunction creation between two semiconductors, that is TiO2 and MOS2. The holes created in the valence bond of TiO2 jump to the valence bond of MOS2. Then it created uh, electrons in the conduction band that jump to again the conduction band of TiO2. And this is how we actually establish the charge separation between the holes and electron pairs created during a photocatalysis. So this charge separation helped in extended photodegrading ability of this material. And some of the adsorption kinetics, the same material was utilized for removal of heavy metals. Like you can see the specific applications for removal of lead and silver here. But we did it from a mixture of 17 heavy metals. That means a solution that contains 17 heavy metals. From there they have selectively removed say silver, barium, bismuth, lead, copper, and titanium. That means it has got high selectivity for these material, mostly for lead and silver. But again, if we utilize it for a particular materials solution of a metal, it will have more of ability, because there is a competition between the 17 heavy metals.
Excuse me, sir.
Yeah, do I have
Sir,
more time?
actually, hello. Excuse me, sir.
Yeah. Yes, yes.
Sir, actually, we are running out of time.
Okay, I'll
So,
finish.
if
I think,
yes,
yeah, I reached almost there. So these are some of the data. This is the structures. I will skip this material. This is another silver and polymer composite that we are making, and we have already filed the a patent for this. And then the conclusion is that there will be one stone, but you can kill two or many birds. So inorganic nanostructures, so multi-component inorganic nanostructures can actually help us achieve multifunctional applications. And uh, they also help us to regain the nanostructures in the solution. And that's all. This is some photographs of our lab with the PhD students and other faculties in our lab. This was the last conference that we attend in person in Goa, BITS Pilani, Pani Water Conference in March 2. So most of the work that I presented in this talk is done by Mr. Deepak here, standing here next to me, and Mr. Abhishek and Mr. Om. And I now have a group of students who are working with me, and these are my collaborators, some from India and some from abroad. And that's all. I thank you all for your patient listening. Thank you.
thank you very much, sir, for exploring the various inorganic nanostructures which are have applications in a wastewater treatment. Sir, there is one question
Yeah.
for a bacterial membrane. How can we functionizing the uh, nano particles?
For
For
bacterial
bacterial
membrane,
membrane, how can we functionize the nanoparticles?
okay, I didn't get the question properly, but I think somebody wants to ask to adsorb bacteria on some material. How can we functionize that kind of material, or how can we get more antibacterial efficacy out of a membrane? So, if you see, most of the bacteria are negatively charged when placed in their zeta potential is negative. So, if your material is surface or the zeta potential of your membrane is more positive, then it will definitely help in more contact with your material. Bacteria and material, they will see each other more often, so that's a possibility. But if you see the antimicrobial mechanisms, there are different mechanisms. Contact killing is one of the mechanism, but there are other different mechanisms by which you can inactivate a bacterium or a group of bacteria. One such popular theory is generation of reactive oxygen species. So that will those are oxygen species like hydroxyl radical, superoxide anion radical, or H2O2. If you have some material which after going into the water can generate or produce such kind of ROS, that will also help in bacterial inactivation. That is one way. And another popular research which people are now doing, not in our country but in other countries, that 3D printed matrix. They will print different matrix using a 3D printer, and thereby they can actually manipulate with the surface structure of the host. But then there will be bacteria immobilized on the nanostructure, but in that case the bacteria will be utilized for scavenging of heavy metals. So that is another use of surface modification of any nanostructures or a structure host with bacteria. That's another kind of thing. So that is not for antibacterial efficacy, rather using bacteria for scavenging other contaminants like heavy metals or organic pollutants. I don't know whether I'm able to answer the question properly, but this is what I understood. Yeah.
Thank you very much, sir, for spending the time for us. Now we will move to the next session.
Okay. Thank you.
Thank you, sir. Thank you, ma'am. Coming upon next, now I request Dr. Achlesh Dagale to deliver the plenary lecture as a speaker of this session. I would like to invite Dr. Leena Patil as session chair. Over to you, madam.
Good morning. I heartily welcome Dr. Achlesh Davede, Assistant Professor, Doon University from Uttarakhand. So, sir, over to you.
Yeah, thank you, Dr. Lena. A very good morning to all of you. And the previous speaker talk about some of the nanostructure and its application for dye removal as well as heavy metal removal. And mine is also a little bit similar in terms of dye removal, but with a different material. So I'm sharing these slides, and I hope that you will let me know. Is it this slide visible? Can you see the slides?
Yes, sir.
It's in full screen. Okay, so my talk is about valorization of waste pine needles for environmental remediation. So basically, why we have selected the pine needles, since as just now introduced that I am from Doon University, which is located at Uttarakhand, and the Uttarakhand, which is mostly covered with the forests, and in this forest, the pine plant, pine tree, it's mostly covered almost 16 to 18% of the mountain in the Uttarakhand, right? And then this, because it's huge amount is there, then as you can see, these are the pine, its leaves, and during the March to June season, the trees shed these pines, pine needles, and once it is dry, you can see that is huge amount. People can use it for various purposes, but in forest reserve area, there this cannot be possible. And then since it is dry, it is highly inflammable, and that's why it is very easy to catch fire. This fire can be it can be intentionally, and sometimes it is accidentally, sometimes it is natural, and sometimes it is for different purposes. But the thing is, when these pine needles are uh, these trees, they shed it into the ground, and there every chances that they can catch fire. So that's why we selected that this kind of biomass is available in huge amount in this region. So we thought that why not we can valorize this pine needle biomass for some value added products. So basically, what we did, we collected this pine needle from our university campus as well as high altitude region as well, and then we paralyzed it for biochar preparation. This biochar, as I said, that we collected it from Doon University, from that is comes under the low altitude region and then high altitude region. We characterize them, the biochar in as per their different characteristics, and found that it is not that much significant different. And that's why for further studies, and in most of these studies, we have collected these pine needles from the university campus, and then we prepared the biochar using slow pyrolysis method, where we kept it the biomass into the furnace under oxygen free conditions, and we provided the nitrogen into the furnace, so that the anaerobic and or anoxic conditions maintained in the furnace. Then the prepared biochar was, further characterized with various properties, physicochemical properties like its surface area, its porosity, and maybe some other, characteristics. And then depending on that, as we all know that the biochar has multiple applications in various fields, be it, pollutant removal from aqueous environment, or maybe as a soil amendment. So we have tested this prepared pine needle biochar as an adsorbent to remove the uh, you know uh, azodize from aqueous solution, and also as a soil amendment. The other important application which we used during our research is that we used it as a immobilization support for enzyme immobilization, because enzymes are very biological agents, and their preparation and their purification is bit costly process. So we want that a support material where we can immobilize and we can use its catalytic activity for various purposes. For our purposes, we used it for the again, decoloration as well as degradation. So the first thing, as I said, that we valorized it as a biochar and tested it for its adsorbent properties, right? To remove different dyes. So, like this is the normal thing we do in research. Like his previous speaker also said that we selected a cationic dye and an anionic dye. So in our case, we selected the methylene blue as a model cationic dye and Congo as a model anionic dye to study the adsorption uh, properties of pine needle biochar. But the biochar activation is one of the key step to to selectively modify the biochar surface for a particular dye adsorption. So here, since the methylene blue is a cationic dye, so the pine needle biochar we activated using strong acids as well as weak acids, and we prepared a strong acid activated biochar, pine needle biochar, and weak acid activated biochar. That is for methylene blue adsorption. For anionic dye Congorite, we activated this biochar using PEI, which is polyethylenamine. As you can see the structure, it has the main thing is that it has amine groups, right? So these amine groups, if we attach on it, so it will give it a positive charge, and this positive charge can be able to remove the anionic dyes. So that was the purpose for activating the pine needle biochar using different agents. And we also tested the adsorption efficiency of pristine biochar and compared it with. These are some of the physicochemical properties of pristine pine needle biochar as well as activated pine needle biochar, and here also it is PEI modified biochar. As you can see in this case, the surface area is slightly increased when we have treated the biochar using strong acids as well as weak acids. With the strong acids, the surface area is little bit more, much more significant increase was observed. That was because the acid, which is harsh in conditions, harsh for biochar, they created some more pore, extra pores, which increases its surface area. The other thing is that since we are using the strong acids, so of course the material which we obtained had a slightly acidic pH, that is 4.7 pH. In case of PI modified biochar, here you can see that again in this case the surface area is significantly decreased, right? This is because the PI coated a layer onto the pine needle biochar that we have verified through SEM images and other techniques like FTIR and all that we will see. These are the SAM images of acid activated biochar. As you can see here, this is the pristine pine needle biochar. Its surface is relatively smooth and compared to the acid treated activated biochar. And this, because these are harsh, just now as I said that these are the harsh chemicals, so they create some pores, and that's why we observed an increase in surface area of the biochar. Then this is the again here you can see that this is pine needle biochar, pristine biochar, and this is PEI modified biochar. Here the thing is the opposite. As you can see, this PEI modified biochar is much more smoother than this pristine biochar, and that is because we the PEI is get coated and create a layer onto the biochar surface. um, the ADS analysis also suggests that you can see here that the amount or percentage of nitrogen is increased in PI modified biochar. That indicate that our PI or amino groups are adsorbed or create a coat onto the biochar surface. When we see the FTIR characterization of this pine needle biochar and the activated biochars, we can see that as we in the first figure, we can see that this is the pristine biochar, strong acid activated and weak acid activated. So there's not much difference between weak acid activated biochar because it is not that much harsh. The only thing we can see that the slight shift of this peak, which is at 1600 centimeter inverse. So in this case it is slightly moved, but because these are the strong acids, we treated the biochar. In the B case, here we can see there is a new peak was observed at 1705, which can be mainly attributed to the presence of some of the carbonyl or carboxylic groups, or maybe the ketonic groups, which is added onto the biochar surface. In case of PI modified biochar, here this is the PEI modified biochar. Here also we have seen that two key peaks here. One is at 1606, that is because of NH stretching vibration, and 1384, which is CH bending. These two peaks, had been shifted to slightly shifted. This is from 1606 to 1579. That means and also the intensity is also much more sharper here. So this indicates that the PI is attached to the biochar surface, and that was we wanted to do. These are some of the visual results which shows that the activated biochar, pine needle biochar, is highly efficient in decolorizing or maybe the absorbing the different types. This is PI modified biochar. You can see it is clearly visible. Then, as a normal thing, we also did the adsorption isotherms to calculate the various kinetic parameters as well. And as you can see here, the for methylene blue, in all pristine biochar as well as acid activated biochar, the Langmuir isotherm was the it is the best fitted in this Langmuir isotherms. In case of Congoride, also using PI as well as pristine pine needle biochar also, here also we observed that Langmuir is the best adsorption isotherms. This is the overall summary of the adsorption results, which we can see that for methylene blue and for Congoride, and we compared it with the our result and with the literature. So these three are our result. And as earlier mentioned, that the activation increased the surface area here, but in case of PI modified biochar, the surface area significantly decreased. But the important is its maximum adsorption capacity for methylene blue. As you can see, it is for strong acid activated biochar, it is 153 milligram per gram, and it is almost comparative to many of these studies which has been conducted by different researchers around the world and reported using different type of biomass. Right, so only here you can see this. The seaweed is excellent adsorbent with perfect adsorption capacity for methylene blue. But this is also relevant because we also need to look about that the availability of biomass. So this biomass is available in our region, so we can select it. Similarly, you can see that for Congoride also, right, it has a very good adsorption capacity, PEI modified biochar, and compared to the literature. Then the another important aspect of any adsorbent is its reusability. How many times we can reuse it for the adsorption purpose. And here you can see that especially the strong acid activated biochar, it shows even after 5 cycles also it shows very good adsorption efficiency, that is dye removal efficiency. In case of this is for pi modified biochar. Here also you can see that after even fourth cycle, here you can see the adsorption capacity is more than 50%. So overall, the conclusion of the pine needle biochar as adsorbent is that it when we do the chemical activation, it can alter its physicochemical property. And not only that, it is highly efficient in adsorbing the model dial which we tested. Of course, it has to be seen that whether it can be able to absorb the mixture kind of dyes, because in the environment we don't have a single dye, we have a multiple dyes, right? It is a mixture in real wastewater, so we also need to have to check whether it is able to absorb the mixture of dyes. Then the second application we checked it's as a support material for the enzyme. So for environmental application, we know that lacase has a very wide application, and it is also able to degrade various kind of azidides. So here what we did, we immobilized, we used this pine needle biochar as a support material for immobilization of lacases. And then we also did the optimization of enzyme immobilization, that is different conditions, pH, how much dosage is required, the temperature, those things we optimized. And then we characterized the immobilized biochar, in terms of its whether it is active or not, whether it is immobilized or not. So based on various parameters, various analysis like SAM, EDS, FTIR and all. Then it is also important that we need the enzyme which is bound or adsorbed onto the biochar surface should be active, should be stable, right? So it's stability study also we have done using by varying pH, temperature, and its storage as well. And again, as earlier we tested the reusability for adsorption, so here also we checked the reusability of the enzyme immobilized on the pine needle biochar. So this the overview here. In this case of pine needle biochar as a support material for lacases, we use the malachite green as a model dye, right? And which is we know that it is highly carcinogenic and has very toxic effects on the on us, on humans, as well as environment. So we did the decoloration assay, degradation assay. So decoloration assay, basically we did that how much dye is adsorbed onto the biochar, right? So for that we first degrade the or deactivated the lacase which is adsorbed onto it, so that we can check that how much is removal is due to adsorption and how much is due to the degradation or maybe the enzyme activity. And after the treatment of dye solution, we also tested its phytotoxicity assay. So these are the some of the optimization results for enzyme immobilization, and we can see that the lacase is able to, the maximum enzyme immobilization was observed at a low pH, that is 3 pH. And in case of enzyme loading, how much enzyme is required for the, is needed to immobilized on that particular biochar. So we varied the different dosing and see the immobilization, enzyme immobilization study. So we observed that this particular unit is enough to maximize the immobilization on the biochar surfaces. Then the temperature, it is we varied the temperature between 20 degrees Celsius to 60 degrees Celsius, and we can see that at 30 degrees Celsius the maximum adsorption was there, immobilization was there. Then at a high temperature, the of course the enzyme is start deactivating due to a high temperature. So that's why the optimum temperature we observed at 30 degrees Celsius. Then we check the stability of free enzyme. As I said, that stability is important because sometimes it may be possible that some of the functional groups of biochar is attached to the active site of the enzyme. So to avoid that or to cross check that, these things are not happening, we have to check its stability, and also its stability, whether it is whether it is by changing the pH, how much it is changing, or maybe other environmental parameters, how it is activity is there, is it stable or not. So we checked with the free enzyme as well as the immobilized enzyme. And as you can see in the pH, that in this region, pH 3 to 6, it is almost very good activity. And even after at pH 7, the activity is about more than 50% activity is retained by the immobilized enzyme. In case of temperature also, we say that of course, as earlier we have seen that at higher temperature, of course, the activity would be less. But we have observed that even after even at 65 degrees Celsius, the activity, relative activity compared to the free enzyme is also very high. Then the storage capability also, we see that it has very good storage ability, and we can store it. We tested it for 4 weeks. So for 4 weeks, we can store it, and it's still able to retain its activity for more than 55%. Then, as I said, the number of cycles, how many cycles it will be able to retain the activity, that also we checked. And we can see that it is more than 50% relative activity is there even after 5 cycles. So that is the best thing which we can say, that is a suitable candidate as biochar as a support material. Then here we saw that we want to do more analysis to know whether it is really adsorbed onto the biochar surface or not. And as you can see here, this is the SAM images. It is because enzyme immobilized, so it is a little bit smoother compared to the this pristine biochar. And also here also we can see that the nitrogen content is increased in the ADS analysis, which suggests that the nitrogen that means the enzyme is attached or adsorbed, or maybe the attached onto the pineal biochar surface. The FTR spectra also revealed the same thing, that some of the carboxylic groups are attached onto the surface of the biochar. Then we did the batch studies to decolorize and degrade dye, malachite green dye, and we have checked its degradation using the HPLC. And as you can see, this is the treated one, where we have seen that there are several peaks for not present here, so that means the dye is degraded. But that was not the enough to confirm whether it is degraded or not, so we did the GCMS analysis as well. And through GCMS analysis, we would be able to identify that these are the different intermediate which are already reported, that these are the degradative products or degradative intermediates of malachite green. So this confirms that the enzyme which is immobilized on the pineal biochar is able to degrade the methylene green. So it's not only the adsorption, it is also simultaneous degradation as well. So simultaneous adsorption as well as degradation of azodyes can be possible by using the pineal biochar as a support for enzymes. The phytotoxicity assay also is quite well, as we can see that these are the untreated dye, these are the treated dye, and this is the control. So where no dye is used. So treated dye, we have seen that compared to the control, the germination is also quite good, as well as the the decrease in mean shoot length and root length was also almost negligible. As you can see here, the height is about 12.15. It is in and here it is 8.9. While the untreated dye, you can see it is too much decrease. So that means it is because it is highly toxic to the plant. So that's why its germination was and its root shoot length was decreased. So overall, if I would like to conclude, the pine needle biochar is support for degradation. So we can say that lacase is successfully immobilized on the biochar, and it has good immobilization yield, more than 75% immobilization yield was observed, and it has wide range of usability in terms of environmental applications, so that we can have a various pH temperature we can use it. And more than 85% dye was degraded in a short period, that is 5 hours. And even the phytotoxicity analysis shows that the toxicity is reduced when we treated it or maybe degraded it using the lacase enzyme, which is immobilized on the pine needle biochar. So in general, in all, we can say that it is a good adsorbent, good immobilizing agent for lacase enzyme, and the other applications, other enzymes can also be adsorbed onto it. Then we also tested, since the biochar nowadays, a lot of research is also going on that it can be used as a soil amendment to phyto extract the various pollutant, particularly the heavy metal can be phyto extracted using the plants and using the biochar as a soil amendment. But there are the various studies, various mechanisms are there, and some shows that it has a negative impact on the phytoremediation ability and all. So that's why we also tested the pine needle biochar as a soil amendment for the phytoremediation of cadmium contaminated soil using the Biden plosa as a plant. And we used the plant growth chamber to study this experiment, so that the most of the things we can control. And once the experiment is completed, we had done various analysis like plant analysis, metal analysis, soil analysis, soil different soil microbial activity, and as well as physicochemical characteristics were also checked. So this is the design which we did. Like we had a control, then we have a metal treatment. So that is the cadmium we selected as a model heavy metal, because the Biden plosa is recognized as a cadmium hyperaccumulator. Then there's a biochar treatment, that is 100 is means 100 milligram per kg biochar was added, and it is the combination of metal biochar treatment. So by metal concentration was fixed, that 20 milligram per liter, but we changed the biochar concentration. At two concentration we have tested, so it's low concentration 100 milligram per kg and 200 milligram per kg. These are the incubation conditions which we used during the phytoremediation studies. And as expected, when we add the biochar onto the soil, and it has to it is going to change the pH, because usually the biochar has basic pH. And as we similar things we observed here, that when we add it in the in soil, where we added biochar into the soil, so the pH is usually slightly increased compared to the control, or where we don't have biochar, right? The other thing is like soil organic carbon is also increased, because we are adding the extra biochar, which is a carbonaceous material. So definitely it's soil organic carbon is also increased. Then we check the after incubation of 40 days, we check that whether it is going to affect any soil enzymes. So two standard enzymes we have taken, like urease activity as well as alkaline phosphatase. So though the effect was not that much significant, but what we observed that the urease activity decreased in presence of biochar, as well as in presence of metal. So this could be probably because for 2-3 reasons might be there. One is, in case of metal is toxic for urease, particularly cadmium, so that's why urease activity is low. And the other thing it might be like the biochar. It is going to absorb the inorganic nitrogen, that is ammonium nitrogen. So probably that is also could be the reason that the urease activity decreased, though not that much significant difference was observed in case of alkaline phosphatase enzyme activity. Similarly, the other important thing what we observed, that the chlorophyll content was also almost similar, so it is not going to affect that much, though slightly we can say in presence of metal, heavy metals, cadmium, in presence of biochar, the chlorophyll content was high. Similarly, the proline concentration was significantly high in the plant. So this indicates that the plant is in under stress. So it is under stress because of metal treatment, and also probably because of the biochar addition. Because once we add biochar, the plant will be able to uptake more metal, and it will create more stress onto the plant. So, but these things need to be confirmed through metal
Excuse
analysis.
me, sir.
Yes,
Excuse me, sir.
yes, yes.
We are running out of time.
Yeah, just 2 minutes. I'm just finishing in 2 minutes,
Okay,
right?
okay, sir.
So the effect of biochar on plant growth also we observed. So as you can see, compared to the whenever we have metal treatment, the it is toxic to plant. So the plant growth is not that much, as its stem height was not that much high. And whenever we have biochar, so it able to improve the plant height and also the biomass. Then the most important part is whether it is able to accumulate or not heavy metals, right? So as you can see here, the best concentration is 100 milligram per kg of biochar, right? And it able to accumulate more cadmium compared to the control, that is only metal treated, right? And similarly, we also checked the bioconcentration, various bioconcentration factors like translocation factors. So translocation factor also slightly improved. That means the route to shoot transfer of metals is was observed in presence of biochar. Similarly, the bioconcentration factor, which is the factor which shows that the metal concentration in plant versus soil. So it is above around 5. So that means the bioconcentration factor for shoot. So shoot concentration to soil metal concentration is ratio is 5.1 in case of when we use the biochar at 100 milligram per liter. So overall, this study also says that the pine needle biochar as a soil amendment had positive effects on the overall plant growth, but it won't able to decrease the stress due to the heavy metals to the plants, right? And it also doesn't able to reduce the stress or maybe the negative impact on urease activity. But overall, we observed that the biochar was able to support the plant growth and the phytoextraction ability of the Bidentlosa. So this is the overall, conclusion of my study, that it can be pine needle biochar can be a promising adsorbent. It is a low cost adsorbent, and it is easily available at least in the region. So locally also we have to think, and it can be use the wastewater treatment as well as for phytoremediation also studies we can use it as a soil amendment. So thank you. This is my team and the projects which we have got funded through a SERB and UGC, and the adsorption work is mainly carried out by Deepshikha, and who is a PhD scholar in our department, in our school. And the phytoremediation studies was performed by Sheetal, who did her master MTech dissertation with us. So thank you. So if you have any questions, you can please ask.
Thank you, sir, for such informative talk about the by-need biomass valorization. Thank you very much, sir,
Yeah.
once again. Now we
Okay.
will move
Thank
to
you.
the next session.
Thank you so much, sir. Thank you, ma'am. I now request Dr. Dipankar Ghosh to deliver the plenary lecture of the session. The topic of his plenary lecture is System Biology Approach to Screen and Identify Algal Phosphatases for Detecting Heavy Metals, a Sustainable Platform. I would like to invite Dr. Nina Patil as the chairperson of the session. Over to you, ma'am.
Thank you, Dr. Mohammed. I feel extremely privileged and honored to be given this opportunity to welcome Dr. Deepankar Ghosh. Good afternoon, sir.
Good afternoon. Am I audible?
Yes, sir. Yes, sir. You are audible. Dr. Ghosh is Assistant Professor at Department of Bioscience at JIS University, Kolkata. His research interest is microbial engineering and algal biotechnology. He has completed PhD from University of Montreal, Canada, having PBEEE doctorate merit scholarship from Government of Canada. MPhil from Annamala University and MSc from the Calicut University, India. He has qualified and completed a short-term course on forensic science from the University of Cambridge, UK. He has pursued his research work as a postdoctoral research associate and research fellow with a full scholarship in different prestigious organizations like the University of Cambridge, UK, Empirical College of London, UK, Pasteur Institute of Paris, France, McGill University, Canada, Pusan National University, South Korea, University of Turkey, Finland, and IIT Kharagpur for diverse academic and research purposes. He has already published more than 100 peer-reviewed high-impact research articles, book chapters, conference proceedings, and scientific magazines. Moreover, he has been funded with industry-sponsored research projects to support his research activities at JIS University, Kolkata at present. Currently, he is supervising 4 PhD research scholars, 70 MSc research projects trainees, and 4 internship students. Today, sir is going to deliver the lecture on Systems Biology Approach to Screen and Identify Algal Phosphatates for Detecting Heavy Metals, a Sustainable Platform. A heartily welcome to you, sir. Over to you, sir.
Yeah. Thank you, Dr. Palit, for a great introduction. So maybe I should share the slides and let me know whether it's visible or not. Yeah. So, is it visible, madam? Yeah.
Yes, sir,
Is
it
it
is
visible now?
visible. Yes, sir, yes.
Am I audible? Hello?
Yes, sir, you are audible.
Hello?
Yes, sir, you are audible.
Am I audible, madam? Screen is visible?
Sir, screen is also visible and you are audible.
Thank you very much. So,
Okay.
thank you very much. So, today, the talk that I'm going to deliver, it is on the systems biology approach to screen and identify the algal phosphatases for detecting heavy metals. I would say it's a sustainable platform. You can see like how it could be. So, this would be like organization, the way I would like to make a very brief outline what we have tried out in last year and end up with some kind of take-home message that we can implement in the wet laboratory experimentation. So I would like to give some kind of very primal rationale for it, followed by some computational experimental design that we have tried out in our laboratory. We get some kind of tentative results that based on we are continuing our work and make some kind of take-home message. I wouldn't say it's a conclusion because it's a start, beginning. So So that should be kind of take home message for that. And I would also put some reference. If you are highly interested, you can go on through the paper. So as you know that heavy metals has a tremendous toxicity. So toxicity is not only on the human health, it also affects the plant microbe interactions within the soil ecosystem and any part of the environment. So environment management for recycling of heavy metals, and before you recycle it back by assimilation process, it would be a good idea to identify, to quantify what extent the heavy metal contaminations are actually occurring within that particular soil or any kind of environmental or health habitat. So I would say, as a microbiologist, we would like to identify what kind of microorganisms are getting highly affected by the toxic impact of these heavy metals. And they're directly or indirectly influencing the metabolic pathways and their corresponding enzymes, and somehow minimizing their potent activities that allow to maintain the soil ecosystem or environmental impacts. So as you know, that pathways which are mostly being relevant with the enzymes. So enzymes are highly affected by the heavy metals, because metals sometimes, either it could be divalent or the monovalent metal ions, they are influencing the catalytic site of an enzyme. And the enzyme will somehow get inhibited in different forms. So that would ultimately make an enormous detrimental impacts on environment and ecosystem. So that's why even if the heavy metal contamination is there, we can carry out the recycling. First, we have to identify the point or location. Really, that location has been influenced by the heavy metal contamination or not. So that will require some kind of proper real-time monitoring. And it requires some kind of system or platform that will allow to identify or screen the presence of those heavy metals in diverse spectrum of this category. So in general, there are broad spectrum of approaches do exist that already allow to detect the heavy metal contamination in ecosystem by biochemical process, by physicochemical process, and also by using microbial factory. So here, what we have trying to do, we try to find out some kind of algal phosphatases. As you know, that algae is the most primitive microbial regime in this universe from the very beginning of the development of Earth. So we try to see some algal phosphatase which could have some kind of extreme tolerance level, as well as they can easily available in any other location. So you will find algae in anywhere, even from extremophilic to very cycrophilic conditions. And mostly the phosphatase enzyme is very versatile, and they do exist in everywhere. So that's why we have been pointing on that particular class of enzyme and class of regime of algal species. Usually phosphatase, they do carry out the breakdown of phosphodiester molecules, and it will ultimately give rise to the soluble or inorganic phosphate that will be soluble. However, its catalytic efficacy has strongly been inhibited by presence of different trace metals, likely heavy metals. This particular feature is actually attracts us to pinpoint on that particular segment of algal phosphatases that will may allow you to understand and allow to quantify, even if the heavy metal contaminants are present in very minute concentration and quantity in those habitats. So that is the major rationale that the present study will allow you to identify, allow you to accelerate or agitate the process to finding out some novel algae-based putative alkaline phosphatase. And we do also carry out some classifications, categorizations of those alkaline phosphatase by means of in silico characterization. And then we try to find out what are the most suitable forms of phosphatases based on their enzymatic affinity. You could say this could be avidity towards the diverse heavy metals, especially we found cadmium and mercury. So that's the very, very simple aim we put forward in the last year, that will focus on the in silico screening and identification of algae-based alkaline phosphatases following the system biology approach. It's kind of a development of model enzymes, and that will sometimes putative, but the putative sequences can be in silico functionalized, by means of some crystal structure which are already available in the PDB database. So that's why we try to make a system through which can able to identify certain class of putative enzymes and do some in silico identification to fetch out the efficacy of those phosphatases, whether it will allow to quantify those heavy metals. So this is basic and very simplistic workflow I have been depicting over here, through which you can easily identify. And it's quite simple. You need to know a little bit on some bioinformatic tools. And the thing is like you have to categorize and you have to make a model out of it. So first, what we have tried to do here, we choose some kind of diverse ranges of, either it could be microalgae, it could be macroalgae, some specific eukaryotic algae you can also consider, because a lot of protein sequences on algal phosphatases are available in KEGG. Some protein structures and protein sequences are also available in big data set of UniProt protein database. And then we try to retrieve those protein sequences. Those who are already correctly, successfully annotated have been undergone for multiple sequence alignment to find out the specific catalytic domain and motifs. Those who are really having some kind of speculative or predictive ideas that may could interacts with some kind of metal ions. It not necessarily at the very beginning we thought like it could only be focusing, or it could have some kind of higher avidity for heavy metals, but we try to find out what are the catalytic metal ions or cofactors that actually interacting with those class of enzymes. And then we have performed the multiple sequence alignment with the cluster W. And we try to find out the molecular evolutionary status by doing phylogenetic analysis, the sequences that we have fetched out from KEGG and UniProt and PDB databases. And we follow the NJ algorithm, neighbor joining algorithm, to come up with the molecular evolutionary genetic analysis. Then after having this comparative and homology, what we have developed, we identify the specific conserved domains or motifs that give us some kind of primal knowledge that it could be possible. There is a feasibility, viability that we can put forward these techniques into a next level. So that's why we try to carry out the putative protein 3D homology modeling. So we have generated using the EA-doc, and also considers most similar protein models as a positive control. You can say the standpoint that has been fetched out from the protein PDB databases. So this putative 3D model, when we have able to come up with, and then we try to check the quality of the putative three-dimensional structures. And that has already been evaluated by different kind of bioinformatic or computational biology kind of standpoints, like by using or by developing Ramachandran plot, by calculating the global model quality estimations, and also check the Mo probability score. Those indexes are actually allow you to understand whether the putative structure that you have developed based on the 3D homology modeling or by the simulation process that actually have a stable, flexible structure in the three-dimensional space. Whenever you have been trying to carry out the wet lab experimentation, that really work out, or they do have a proper folding in the solution or not, while you have been trying to check the validation experiments. So afterwards, we also try to find out the transmembrane helix. This is very important because not all the phosphatases, they are secretory. So some of them are membrane bound. Sometimes they can do exist within the inclusion body, within the cytosol of the microbial community, especially in algae. They are compartmentalized. They do carry out their proper functioning while they do reside within a specific zones, specific area locations. So that's why we try to find out whether those phosphatases are having some kind of transmembrane helices or not. That will allow you to understand and predict that the enzymes are actually extracellular. They have been biosynthesized within the cell, but they're getting secreted outside. And they do carry out this kind of quantitative analysis and allow to understand whether the metals are there in the external environment. And this finally, the putative protein models have been docked with the selected molecular docking we had performed with the selected heavy metals. So in our case here, we have definitely carried out a lot of interactions at the very beginning, but then we have somehow uh, some kind of thought that maybe it could be highly specific for cadmium and mercury to predict the metal affinity, avidity, and also try to find out what are the most conserved amino acid residues are there within that catalytic domain by using the MIB algorithm. So actually, we have been performed the systems biology by plug and play with different kind of the computational programs, the mingling, merging of different algorithms to simulate the process and come up with some kind of interactability and prediction models. So based on that, while we have done the homology modeling, we have carried out the simulation studies, we have checked out the favor regions, the regions which are highly catalytically sustainable to get interact with the metals by Ramachandran plot. We developed this phylogenetic tree based on the bootstrapping techniques by neighbor joining. And we have found out there are certain distinct characters we have identified that not only the microalgae, the macroalgae can also have some kind of avidity towards these metallites. And but the affinity on avidity index is quite differ from eukaryotic regime to the prokaryotic regime as well in cyanobacteria. And the metal binding affinity algorithm shows some kind of in silico predictions, has clearly shown. We have also checked the simulation process, multi variations we have done. We have doing some in silico mutagenesis to make sure like these amino acid residues are really interactable with those metallites or not. So we have find out some micro or special some microalgae like Senicocystis, Senicococcus, Lingbia. They do have a higher, the predominant alkaline phosphatases that can be used as a sensor enzyme that will allow to interact with a higher potentiality for the cadmium. In the similar way, we have also performed this experiment to identify the sensitivity of the enzyme alkaline phosphatase for the another heavy metal that is cadmium, and we have find out they do have some kind of interactability, having some free energy change, some MIB score for the mercury as well. When we have identified that, okay, this class of algal phosphatases, they do have an affinity for those two classes of metal ions, which are heavy metals, then we have to find out of this categorization, out of these 4 or 5 alkaline microalgal phosphatases, which are secretory. That is very important because not all the alkaline phosphatases, while they do have interactability of the metal ions, it does not always assure you that it could be really working out in vitro conditions while you have been trying to carry out in the nature. Because nature has a lot of constraint, a lot of obstacles, a lot of inhibitions. They can also destroy the enzyme. So feasibility, stability of the enzyme, and the secreted nature of this enzyme quite plays a very important role to is to apply in the nature as such. So we did the secretory nature fetching out, and we did the TMHH analysis that will allow you to understand the transmembrane helices, whether or not we find out the alkaline phosphatase that we have identified for mercury as well as for the cadmium. We find out of 4, 1 or 2 candidates are really highly secretive in nature. They do not contain the transmembrane. They do not have the anchoring subunit with their enzyme. So they are definitely going to be get secreted outside. And we have also checked the sequence homology with some other non-algae based alkaline phosphatases to assure that they do have a similar kind of molecular conformation or the orientation of amino acid in their catalytic secretory domain. So that was the very, very simple work we have carried out. We have been continuing this work. And so we have identified there are certain Senicococcus, Senicocystis, or Lingbia algal species or their associated alkaline phosphatase. They do have a higher potentiality and feasibility in future for cadmium and the mercury toxicity determination. And also TMHHM analysis, the transmembrane helix analysis shows that some of the alkaline phosphatases, they do, some of them they does not have the transmembrane domain. So that will allow you to cause a slow or no release of those enzymes. But we find some algal phosphatase, they really doesn't have the transmembrane domain, so they are highly possible to get secreted outside, and they do carry out what kind of in vitro study we wanted to perform. So that's the future outlook of this. So proper in vitro and in vivo validation requires to be performed. And finally, whenever these enzymes will be, that those are already predicted, there needs to be carried out crystal structure analysis by following the dynamic simulation analysis to develop the trajectories, develop the three-dimensional structure, their folding, their movement within the buffer as a future upgradation of this to improvise the protein model accuracy and better data interpretation that will allow to give you maximum quantification of those metals, especially like cadmium and mercury. So this is actually the data that the paper we have published in Spink and Nature. So if you're interested, you can go on through this. And so finally, I'm come to an end. So I would like to acknowledge, firstly, Dr. Pankaj, who actually gave me an invitation. Thank you, Pankaj, for your great invitation. I would also like to thank organizing committee of Sandip University and also Society of Green Environment, New Delhi. Finally, Department of Biosciences, JS University, and all the participants over here, those who are listening and enjoying the story. Thank you. So this is my small group. We have been working last 4 years at JIS University and try to develop our lab. So still our lab is a budding lab. We are looking for funding. We are looking for more collaborations. Thank you very much. So I hope you enjoy.
Thank you, sir, for the informative session on algal phosphatase for detecting the heavy metals. Uh, and we will like our we were over to you, Purnima madam.
Thank you so much, sir. Thank you, ma'am. Ladies and gentlemen, we will take a short break now and then we will start with our oral and poster presentation at 1 p.m. Okay, thank you.
Yeah, Dr. Palit, am I audible?
Yes, sir, you are audible.
Yeah.
Thank you very much, sir, for this informative session on algal phosphatase for the detecting heavy metals. So there is one question. Can you please
Yeah.
elaborate about the simulation and its accuracy?
Yeah, it's not very new technique that people have been trying out, and even we have tried out. So the thing is like that entirely depends on because while we have started the work, so we have chosen those protein sequences, those were actually solved crystal structures, and 30% or 40% those who are targeting, we are targeting those sequences, those who are not properly sequenced even they are not properly identified. That's why I say it's a putative protein sequence. And we have do homology modeling that will allow you to give you some kind of primal idea. They can allow to give you some putative crystal structure based on the references those were already solved by the crystal structure. So this is the only way out at the very beginning. Now when at this particular stage right now, if we want, those sequences can be overexpressed and that can also be get crystalline so that we can carry out the crystallization. So the simple answer of your question is yes, it is accurate, but it needs to be get validated by in vitro experimentation. That could only be possible if those protein sequences are going to be cloned. They will be get overexpressed. They will be get purified by affinity chromatography, and then followed by the crystal structure analysis. So initially, we are We need to do XRD analysis, FTR analysis to identify those structural things or functional things, but I wouldn't say these will allow you to give the proper idea. The only solution is to carry out the crystal structure analysis and then perform the in vitro study. Thank you.
Thank you very much, sir.
Thank you. Thank you, madam.
Now, now we will reach at the end of today's session, and all the audience are going to join the for poster and oral presentation at 1 p.m.
Good afternoon all. We will now start with the oral and poster presentation. Now I request Rishika Piyush Kumar Mistry, and the topic is microremediation. Rishika,
Yes, ma'am. Ma'am, am I audible?
yes, you are audible.
Ma'am, can I start?
Wait a minute. First of all, I will share the screen.
Okay, ma'am.
Is it visible? Rishika,
Yes, ma'am.
yes, you can continue.
Okay, ma'am. So, good afternoon. Myself, Rishika Mistry. I'm from Sandip University. Thank you for giving me this opportunity. So, let's begin. So, topic for my presentation is bioremediation of agricultural and industrial waste. So, first of all, I'll introduce you all to my topic. So, bioremediation is basically defined as the use of biological process to degrade, break down, and essentially remove contaminants from soil and water. Next is bioremediation techniques from which we can reduce the pollution and waste. Bioremediation is a mechanism which utilizes the living organisms to reduce natural contaminants. Bioremediation includes two remediation terms, that is ex situ and in situ bioremediation. Ex situ describes a process where contaminated soil, water is removed from environment by biological organisms. And in situ bioremediation includes the biological treatment of contaminants in subsurface, typically groundwater. Ex situ includes first of all land farming. It, it is the bioremediation technology. It is performed in the upper soil zone or in biotreatment of cells. Composting. Compost is usually a mixture of ingredients used to fertilize. Ma'am, excuse me, ma'am. My poster is not visible.
Yes, yes, it is visible.
Yes, ma'am. So it is performed in the upper soil zone or in biotreatment of cells. Composting. Compost is usually a mixture of ingredients used to fertilize and improve the soil. Next term is biopile, commonly applied to reduce concentration of petroleum in soil. Windrows, as it is also a kind of bioremediation techniques. Next term is in situ bioremediation. So it includes the terms like bioventing, important bioremediation techniques for degrading organic contaminants with microorganisms. Second term involves phytoremediation. This method or technique use living plants to clean up the soil air and water contaminants with hazardous contaminants. So as we have seen the bioremediation to reduce the contaminants, it is also important to know that from where this pollution occurs. Man-made pollutants. It involves two major problems that are agricultural pollution and industrial waste. Now, this kind of pollution refers to biotic and abiotic byproducts of farming practices that results in the contaminants or degrading of environment and surrounding ecosystem, and also can occur injury to humans and their economic interest. Industrial waste. As we know, most of the pollution is caused by industrial waste products and improper disposal of waste contaminants, the soil with harmful chemicals. These pollutants affect the plant and animal species and local water supply and drinking water. Objectives and applications. As you can see in the image, there are some useful microbes which are injected in the soil. So here the oxygen and nutrients take place, and as the oxygen and nutrients are taking place, the carbon dioxide is released out from there and the recovery takes place. So we can see the change from dense to the greenery. Now we are going to see the advantages of bioremediation. So it is completely a natural process with almost no harmful effects. Little energy is consumed compared to the incineration and landfilling. So hence we conclude over here that is bioremediation is an effective technique available to clean up contaminated sites. Thank you.
Okay, thank you. Our next participant is Himanshu Katare Pratik Kumade. Himanshu, are you there? Yes. Device is not connected. You have to connect your mic and camera. Himanshu, are you there? Okay, we will move on the next participant, Rinku Wadhwani, Saloni Sonam. Rinku, yes. Yes, Rinku, you can start. Rinku, are you there? Rinku?
Yes, ma'am. Am I audible?
Yeah, you are audible. Continue.
Yeah. So the topic for the poster is hybrid treatment technology. I will start from the what is hybrid treatment technology and will introduce it. So for the introduction, I will say the bioelectrochemical wastewater treatment via hybrid system is a novel and promising approach to the wastewater treatment and simultaneous production of hydrogen and renewable electricity. As we all know that MFCs, that means microbial fuel cells, are used for the wastewater treatment and generation of electricity as well as hydrogen. But it is cost prominent and the further can't be used. So we use the hybrid treatment technology for the better use and prominent and novel use. The diagram has been shown. here, which shows the hybrid treatment technology. Like there are many biofuels, biodiesels, so which are not convenient as well. So microbial fuel cells generate the electricity directly by degrading organic matter through the electrochemical reactions. Now, for the moving further, to the figure, I will say to the figure that there is a schematic diagram representation of the conventional microbial fuel cells, and as well as the second image shows that how about the hybrid treatment technology takes place and what are MFCs, that is microbial fuel cells, and there are various applications of the hybrid model for which we can generate the electricity via the proton gradient as the electrons are transferring and electricity is generating. The proton-proton interaction generates the hydrogen and carbon dioxide is released in the environment. By concluding my poster, I will say the application of microbial fuel cells and hybrid technology is mainly focused here, and the wastewater is important resource for nutrients, energy, and water itself. Okay, thank you.
Thank you. Moving on to next participant, Roshni Patel.
Yes, ma'am.
Okay, wait a minute. We will share the screen first.
Yes, ma'am. Shall I start?
Yes, you can start now.
Yes, ma'am. So good afternoon, everyone. I am Roshni Patel from Sandip University with my colleague Bhumika Varia. We have made a poster on transformation of vegetable waste into valuable added products. As we all know that the basic need of our life is food, clothing, and shelter. As we know that we all eat food daily on daily basis, that is basic need, and we waste also food on daily basis. But in worldwide, the wastage of food is in great amount. So for that, the wastage of food in great amount, I have come here with some alternatives to be done by the waste food products to be added in valuable added products. So first thing which can be done with the waste food products is that the biofertilizers. The first thing that the biofertilizers is made, that the food is collected from vegetable market, meat, and industrials and residential places. After then the plastic is removed and separated from that. After then the water is sprayed and the food is disinfectant by which the microorganism cannot attack on that. The dehydration is done by which the water molecules are removed out from that. After then, by using of shelter machine, the shelter is done by which the slurry is made, and after the slurry is made, vitamins and minerals are added in that by which were removed out in the dehydration process. After the dehydration, after the removal of water, the pellets are made. The pellets are of two types, that is in veg pellets and non-veg pellets, and the veg pellets are given to cattle, and non-veg pellets are given to dogs and cats. The second thing which can be made by this bio waste is that we can make energy production. For that, the waste food is heated at 160 degree Fahrenheit at 1 hour. After then, it is the manual is added in that, and it is added in digester. After the addition of that in digester, it is allowed to ferment in anaerobic condition and for 20 to 30 days in 100 degree Fahrenheit. The microorganism of anaerobic microbes uh, work on the food material and allows and break down it into bio-waste and biofuels products. And by this, the production of biogas occurs, and which in which 60% methane is occurred and is used for energy production. The third, which is made by, that is lipids and fatty acids by hydrolyzed waste food water. The hydrolyzed waste food water is pre-treated with acids and and after that it is treated with enzyme of 50 different types. And after the dehydration of enzyme, it is being treated with dehydration, by which the process is easily carried out into fermentation, and by the use of microorganism, the fermentation process carried out easily, and it is stored and used in the form of lipid and fatty acids. Third thing that these are some products of these are some alternatives by which we can by which we can give an alternative way for this food waste in best possible way manner. If we consider futuristic aspects for that, is that if we do less wastage of food, so it will be benefit to us only. That if we less wastage of food will be there, so there will be less wastage of money. As it considered that the food is the main source of water, and many of the people are not able to get the food at a time. So at last, I conclude my topic by saying that less wastage of food will save less money, so save food. Thank you so much.
Thank you, Roshni. Moving upon next, Kalyani Kothade.
Good afternoon, everyone. My topic of presentation is how
Wait a minute. Wait a minute. Okay, continue. You have not shared the PPT or poster?
ma'am, I have sent it.
Okay, continue.
Mm, okay. Hello, everyone. Good afternoon. Myself, is how the decomposition or degradation of the plastic degrade by the marine bacteria, and one of the example I have explained is of a species of Pseudomonas estes nigri. So how that cycle happens, uh, we know that plastic is a very harmful for all over the world. No one can consider that plastic is helpful for anybody. It not only affects the marine life, it also affects the in all the environment. So how if there is a problem, then if there is a problem, then for that problem there must be a solution for it also. So how the marine bacteria carries out this problem, how they degrades the plastic, that I am going to explain. So one of the species is a Pseudomonas estes nigri, which is capable of degrading the plastic. And in the plastic, one of the major component has been found out is the PET. PET is nothing but the polyethylene terephthalate, which is a major compound which is used for the production of a plastic. And that Pseudomonas estes nigri have the capability to degrade that polymer. The Pseudomonas estes nigri uh, pre- produces the alpha hydrolysis enzyme, which is capable of breaking down the polymer of the PET. And when that happens, the after the degradation, the monomers are have been broken down. They are they produce two kind of a byproducts called as TPA, such as stands for terephthalic acid, and EG, that is ethylene glycol. And as it is a not totally complete degradation, but there is a incomplete hydrolysis products are also released, titled as MHET and BHET. MHET is mono monohydroxyl monohydroxy ethyl terephthalate, and the BHET is 2-hydroxyethyl terephthalate. Now, not only the marine life is affected by the plastic, and another kind of organism also live in that particular marine area in the marine, such as zooplankton, phytoplankton, and the nekton. If the plastic comes over the surface of the sea, and all these kind of organisms are present near to the surface of the sea. If the plastic goes into the sea, there they create a barrier create a barrier by absorbing the sunlight. If there is a no sunlight, if there is a no sunlight which will not receive by the phytoplankton, the cycle of the phytoplankton, zooplankton and the necton will be also disturbed. So when, if this bacteria is doing such kind of a thing that they are degrading the polymer, and after the procedure the carbon dioxide and oxygen is released, which are considered as the DOM, that is dissolved organic matter, and POM as a particular organic matter. Those carbon dioxide and oxygen goes into the water, and those components are used by the phytoplanktons. And if the phytoplanktons gets this kind of a compounds, the another cycle will be proceed, because zooplanktons are dependent on the phytoplankton, and the nectons are nothing but the cartilaginous small size of a fishes present in the upper zone of the sea. They are also get benefited. And why it is important? Because if one kind of a thing, what if one thing in a cycle disturbs, then the another compounds are also disturbed. So when the pseudomonas esters nigri degrades the polymer PET, releasing last at the last it produces carbon dioxide and oxygen. Those carbon dioxide and oxygen are utilized by the phytoplankton, and they utilizes it. And why they need to utilize it? Because the plastic is present in the water, and phytoplankton perform the process of photosynthesis, right? And because of the presence of a plastic, the the plastic is creating a barrier for the sunlight rich sunlight rich sunlight, which should be absorbed by the phytoplankton. Because of the plastic, it can't reach to the phytoplankton. That's why they use this carbon dioxide and water, which is released by the bacteria in the water. And this is the life cycle. I hope all of you have understood. And now I'm going to explain what is the disadvantages of the plastic. Plastics are typically made from resources that are non-renewable. Absolutely, we know that.
Kalyan, kindly conclude.
Yes, ma'am.
Kindly conclude. Your time up.
Okay, ma'am. So there is only one solution we can say, that don't use plastic. It is harmful for all the world, and nothing else. Thank you, ma'am.
Thank you, Kalyan. Moving upon next, we have Pratik Kumade. Pratik, are you there? Yes.
Yes, ma'am.
Wait a minute. We will share your
Ma'am.
screen.
Yes.
The topic is
Yes, ma'am.
microremediation. Okay.
Yes, ma'am.
Yes, continue.
Ma'am, this slide is not my.
This slide is not yours?
Yes, ma'am. It is not my.
Okay, wait a minute. We will check it again.
Yes, ma'am.
Continue.
May I start, ma'am?
Yes, continue.
Good afternoon to everyone, all the staff members and all my friends. I am Mr. Pratik Kumbarde and my friend Himanshu Katale. We are here to represent a topic micro remediation. Micro remediation means a fungi, and remedium is the Latin word called restoring balance. Is the form of the bioremediation in which the fungi based remediation, the method used to decontaminate the environment. Can you change the slide, ma'am? If a fungi is the natural decomposer of the waste manager and secrete a several extracellular enzyme capable of decomposing a lignin and the cellulose material. The importance of the fungi decomposition is to remove oil, petroleum, livestock, metal waste, pesticide, and the other pollutant from the water. There are types of fungi used in cleaning. Cleaning in the industry is pharmaceutical waste, agriculture waste, heavy metals. Ma'am, please change the slide. There are three types: pharmaceutical waste, agriculture waste, heavy metals. In a pharmaceutical waste, the compound released from the industry or the drugs manufacturing industry are extra extravating is the nothing but the bad situation arise already survival in the environmental condition. A study also showed that the pharmaceutical influences can be a toxic effect to a aquatic biota and other life also. So the micro remediation is used here to make the decontaminate the environment and make it natural as ours by converting it into a natural substances into carbon and soil respiration and nitrification, etc. Agriculture uses. Next slide. Large amount of the pesticide herbicides are used in the agriculture. And those affect the soil, groundwater, or the nearby waste. The water bodies may contaminated. The leaching of the mineral like the nitrogen, sulfur, etc. The chemical present in the pesticides, herbicides like etc. can cause a lethal damage to a reproductive system and the vital organism of the body of the human and the animals such as the kidney and the liver also. With the help of the micro-remediation, the toxic substances are converted to a natural substances, a conversion into a non-toxic metabolites. And heavy metals. Metals are the nothing but the metal which start decomposing in the nature, which are hazardous to a human, such as the copper, mercury, cadmium, silver, etc. After the leaching of the environmental, those metal eventually enters to a human body through a food consumption and the water. To recover this micro-remediation type, the fungi micro-remediation type of the fungi should go all isolated in the needs to which the human and the natural hazardous to control their life damage. Thank you, ma'am. Thank you to Sandip University for giving us this opportunity at this stage.
Thank you, Pratik. Moving upon next,
Thank you.
Kartika Somar.
Hello, ma'am.
Yes,
Ma'am, just slide present, please.
yes, we are sharing. Yes, you can start now.
Good afternoon, everyone. Myself Sana Samsat Pathan and my partner's name Kartika Sonar. Here I am. My presentation topic is the role of microorganism in remediation of wastewater in floating treatment wetland. As you can see on the screen, we will start with the introduction. The floating treatment wetland are small artificial platform that allow this aquatic emerge plant to grow in water that is typically too deep for them. The common bacteria species, rhizosporic and the endophytes bacteria, and their specific role in the pollutant removal process. The plants and microbes community also break down the complex compound to the simple form. Now, the floating treatment wetland are constructed, purposely designed and constructed system based on the physical, chemical, and biological principle. It is useful process to use the removed pollutants from the wastewater. The floating treatment wetland is a novel technique based on a floating vegetated system. Now, the role of plants that are used in this technique is nutrient uptake, extracellular enzyme production, and provide surface area for a biofilm. The biofilm, which is produced by the microbes that are involved in the floating treatment wetland, and they have their roles in this. That is the biofilm formation. Then degradation of pollutants, improvement in plant growth, and denitrification. The denitrification is the process. The denitrification is the process in which the nitrogen is fixed by the microorganisms and is used to plants. Then next is the removal of heavy metals. And the improvement component of the FTV, that is the floating treatment wetland, is the growth media. The different kind of growth media is used in this technique. Then buoyancy, plants and bacterial biofilms and microorganisms. These are plays the important role in this technique. So here we conclude that the microbes, bacteria and algae are the major component of epiphytic microbes which are colonize the lower surface of a floating plant. Bacterial biofilms has an important role in the removal of organism, inorganic and the metals in the floating treatment wetland. And by this, we filters the water and it can be reused again. Thank you, ma'am.
Nice presentation. Okay, next, Snehal Party.
Hello, ma'am.
Yes, Snehal, we are sharing the slide. Wait a minute.
Ma'am, can I start?
Yes, you can continue.
Good afternoon, everyone. The topic for our presentation is vermicomposting. Vermicomposting is a type of composting in which certain species of earthworms are used to enhance the process of organic waste conversion and produce a better end product. Simply speaking, vermicompost is earthworm excrement called castings, which can improve biological, chemical, and physical properties of the soil. We use vermicomposting from a long time, but with today's new technology and advancement in science, it is more advanced and we can implement it for more plant production. Debris and food waste combined account for nearly 30% of the materials disposed in the landfills. These materials can be easily composed in municipal and backyard composting systems, and fortunately, composting collection programs have been increasing with our increasing waste generation. However, backyard composting may not be an option for many individuals that wish to divert their materials from landfill because they lack backyard space, time, or energy, or else live in a rental unit. Therefore, vermicomposting becomes an alternative and best attractive option. The base The basic protocol is to revive the dreams of Sir Charles Darwin for scientific use of earthworms in the sustainable development programs. Vermicomposting technology is emerging as an environmentally sustainable, economically viable, and socially acceptable technology all over the world because with the advancement of science, many new technologies like vermicomposting technology that manages most organic waste, the vermifiltration technology that uses to treat municipal and several industrial wastewater, vermiremediation technology that treats and cleans up contaminated lands, vermi agroproduction technology that produces chemical-free organic foods by worms and vermicompost, vermi industrial production technology that produce viable industrial raw material from worms. So there's a shift from traditional to transitional phase of vermicomposting. First, the use of earthworms as waste managers for efficient composting of food and farm waste and soil managers for fertility improvement and enhanced farm production were known for ages, but now it has been more scientifically and also commercially revived. The other uses of earthworms for the benefits of environment and society are wastewater treatment, land remediation, and production of valuable medicines, even to combat cancer and heart diseases, raw material for rubber lubricants, soap, detergent, and cosmetic industries, and protein-rich feed materials for fishery, dairy, and poultry industries are some of the new discoveries in the field of vermiculture. The typical earthworms that we find in our gardens are not suitable for vermicomposting. These are soil dwelling worms that do not process large amounts of food waste and do not reproduce in confined spaces. Instead, worms commonly known as red worms or red wriggles are preferred because they reproduce rapidly, are communal, and tend to remain on the surface while feeding. There are several species of earthworms that are used, but the most common are Isnia fetida and Isnia andredi. Red wriggles require similar conditions as humans for growth. They prefer room temperature and adequate moisture. So the population of wormbean is controlled through nutrient, food availability, and space requirements. A simple method for harvesting castings and separating worms from casting is used that is called as the dump and sort method. It is an alternative to conventional sewage sludge for composting technology that uses vermicomposting to replace the starting material, so the efficiency of the breakdown and transformation of organic matter is increased by the activity of worms, resulting in the high quality products. The benefits of vermicompost for our plants and the soil is that it creates pathogen suppression, nutrient delivery increases, water retention, increased microorganism population, pest suppression, plant growth regulation, and higher yields, polluted soil remediation. So when we take a outlook over all the inventions and technologies in vermicomposting, it we can conclude that it is a boon to soil and agriculture microbiology. Thank you, ma'am.
Thank you, Suman. Okay, we move on the next participant, Pratik Patil. Pratik, wait a minute. Let us share your presentation.
Good afternoon, my name is Pratik Patil. Today I am very delighted for having this opportunity to present my PPT in front of you. The title of my presentation is Bacterial Detoxifying Pesticide in Soil System. So first of all, what is a pesticide? A pesticide can be any mixture of few chemicals or substances that may prevent, destroy, repel, or mitigate any pest. Example can be insecticide, herbicides, fungicide, and various other substances that are used to control or inhibit various pests. The positive aspect of these pesticides are they enhances the crop production, but also causes drastic reduction in vector-borne diseases. But main problem is that excessive use of this chemical can lead to microbial imbalance, and bioaccumulation of this contaminant in organisms can be health hazardous. We can also see that in Punjab it was known as the breadbasket of India, but nowadays the crop production in that state has fallen. It is due to the microbial imbalance and overuse of pesticide in that region. So the list of pesticide pollutants. Pesticides are mainly categorized into two categories, natural and synthetic. Generally, natural pesticides are get degraded in the environment naturally and are less harmful in nature. But the problem lies with synthetic, as they generally are toxic in nature and are highly stable compounds. We can also see the examples of organochemicals, organophosphate, or carbamates that are the synthetic pesticides. Next slide, please. So, toxic effect of pollutants. Uh, the pollutants are affecting plant, human, animals, and pollinator, as well as the beneficiary microorganisms that are present in the environment. To plants, the pollutant effect also target non-targeted plant species and affects them. On humans, it has very health hazardous effect, as this pesticide get accumulated in the bloodstream and can be very dangerous as well as toxic to humans. In animals, the scattering of pesticide residue kill non-human biota such as bees, birds, amphibians, and other organisms. It also affects the pollinators that are very beneficiary in our ecosystem, and also affect the beneficiary microorganism. You can also see in the picture that the pesticide is getting into the environment and bioaccumulating and causing drastic changes in the environment. We get exposed to the pesticide through orally, by inhalation, also dermal. And next slide, please. Route of exposure of pesticide. The pesticides get exposed to humans through orally, by inhalation, and through dermal contact. The oral exposure is mostly found in kids when the pesticides are not tightly packed or kept in a safe place. It also causes toxicity in humans. The toxicity category is divided into certain range: toxicity level 1, 2, 3, and 4. When we take up to 50 milligram per kg pesticide, we get toxicity of level 1, and it is given in the chart. The toxicity range varies from it depends on the concentration that we are exposed to. By inhalation of 0.2 mg per liter, we can get toxicity of level 1, and also it is as follows, that is given in the chart. Next slide. Pesticide have a toxic effect on organism as well as environment. We can also see that organochlorines such as dichlorodiphenyl trichloroethane DDT, it is the best known example of a pesticide that is used. It takes 2 years or more than 2 years to degrade in the environment naturally. The pathway to degrade it is when the DDT is converted into DDE and DDD, that is diphenyl dichloroethylene. Then it can be degraded into the environment and can cause less harm Among microorganisms, bacteria comprise major group involved in DDT degradation are Bacillus, Pseudomonas, Arthrobacter, and Micrococcus. You can also see the structure of DDT, which is converted into DDE and DDD, that is dichlorodiphenyl dichloroethylene. And next slide. Carbamates. They were introduced as pesticide in early 1950s. They are used as alternative to highly stable organochlorines such as DDD. The degradation of this pesticide occurs through the hydrolysis of methyl carbamate that is linked by an enzyme called carbofuran hydrolase. Microbial strain that can degrade these pesticides belong to genera Pseudomonas, Flavobacterium, Archomobacterium, Spigmomonas, and Orthobacters. Organophosphates. They are the esters of alcohol with phosphoric acid or with some other acids. They are very toxic in nature. Degradation of these chemicals occur through the hydrolysis of p-enol alkyl and p-on aryl bond. Bacteria that can degrade these pesticides are denitrifiers, Desulfomonas, Flavobacterium, and Enterobacterium species. Generally, these bacteria form complex and degrade the pesticide in the environment. So these are my references. Thank you for giving me this opportunity to present. Thank you.
Thank you all participants. Ladies and gentlemen, let us short break and we all assemble back sharp by 2 p.m. Thank you.
Good afternoon, all. Welcome back. I am Savita Patil. Now we are entering in the afternoon session of the conference, and we will again start with invited speakers. So now I request to Dr. Kuldeep Bhatt to deliver the lecture as a speaker of the session. Before that, I would like to invite Dr. Nisar Rishi as the session chair of the today's afternoon session. Over to you, sir.
Good afternoon, one and all. I'm Dr. Nisar Rishi, School of Science, Sandip University, Nashik. I welcome all speakers, scholars, and students to the second session of day 2 of the 3-day international conference on current trends in waste treatment, reuse, and valorization. So our first speaker for the afternoon session is Dr. Kuldeep Bhatt.
Hello, I'm audible.
Yes, sir, you are audible.
Okay, thank you very much.
Thank you, sir. Thank you, sir, for being with us today. Dr. Kuldeep Bhatt is a senior assistant professor, Department of Environmental Science, Central University of Jharkhand, Ranchi. Dr. Kuldeep has earned his master's and PhD from Baba Sahib Ambedkar University, Lucknow. Sir has authored 47 research publications in the journals of national and international repute. Sir has authored 6 books. Dr. Kuldeep has successfully completed 2 major research projects funded by Government of India, and 1 major research project is under process. Thank you, sir, for being with us today. We are pleased to have you as a speaker on this international conference. Sir, I kindly request you to proceed with your presentation as and when you are ready. Over to you, sir.
Thank you very much, sir. Thank you everyone for inviting me and giving an opportunity to share my experience here. Okay, let I share the slides.
Sir, please share your slide.
Yes, please. I'm just wait for 1 minute. I'm sharing
Okay.
it.
Okay, sir. No problem.
It is processing, so I don't think, because I am also using this platform first time, StreamYard. So I think but it is taking little bit more time.
Yes, sir, please.
Sir, are you logged in from the mobile or from your desktop?
Laptop. It is through
Laptop. Okay.
laptop.
So there is a share option. Second option from the right side. Share option is there,
Yes,
and
yes,
you can
yes.
see the screen share. You kindly keep your PPT open, and it will take you to the slide share.
Is it visible? I think studio. I shared slides. Okay, yes. I think now it is visible.
Yes, sir. Yes, sir. It is visible now.
Oh, okay, thank you very much. Myself, Dr. Kuldeep Bodh, as introduced. Uh, the topic of today's deliberation is remediation of metal contaminated soil using an industrially important plant, Ricinus communis. Uh, as we all know that there is due to various industrial activities, minings, establishment of power plants, electric power plants, and industries like cement industry, iron steel industry. So introduction of several hazardous materials, including heavy metals, is a major concern, and of course, environmental pollution is the major one of the major concerns of the entire globe, and due to non-degradable nature of heavy metals, these persist into the environment, whether it is in soil or water, and it is quite difficult to remove these contaminants, heavy metals like nickel, cadmium, lead, cobalt, magnesium from the media. And as these are not biodegradable, so naturally we can say whether we are using the microorganism present naturally into the soil cannot remove, and they can easily taken up by the plants and even edible crops, and contaminate the entire food chain, and therefore we can say it enters into the human beings also. And these are the two examples of the metal toxicity. One is the cadmium toxicity, and another is the nickel toxicity. So these can also not cause the, it is the adverse impact started from very mild symptoms to the very, we can say, uncurable diseases like even cancer, because number of metals are also known as carcinogenic, and they can damage the genetic materials too, and many times cause the mutations and cause the uh, cancers, and even many times death to the human beings. Therefore, there is urgent need to uh, reclaim, to remove the heavy metal contaminants. First thing is there, we have to prevent to reduce the contamination, and if it is already contaminated water or soil is there, so how we can remove. As I already told that it is, these are non-degradable in nature, so nature cannot remove. uh, so we have to find out some important technologies, and in this slide we can see here scientists have developed number of processes, methods by which the metals can be extracted, metals can be uh, removed, like soil excavation, metal immobilization, soil washing, land filling, precipitation, microbial remediation. In case of the metals which can change their forms, or we can say in association with plants only, and application of plants, application of visible plants for the removal of heavy metal is one of the important and economical, cost effective, efficient technologies for the removal of heavy metals from the contaminated soil as well as even water. As this is natural technology because it is based on the plants, so this is also known as solar energy driven system. and it is even cost effective also. Yes, this is the entire, we can say, method, a process of the phytoremediation. Simply plants absorb the toxic metals from the soil or water, especially soil in case of this today's deliberation, from the soil, and the accumulated heavy metals can be translocated towards the aerial parts of the plants. And if the plants only accumulate inside the roots, and the plants are not much able to translocate, the system is known as phytostabilization. But if the plants are efficient and transfer the accumulated heavy metals into the aerial parts, so these are known as phytoextractor plants, and the process is known as phytoextraction. And number of plants have the biotranslocation factor, means transfer from the roots to shoots, more than 10, 20, even many times. Good hyperaccumulator plants have been identified. As this is solar energy driven and nature based technology, in this slide we can see it is cost effective also, because at the same you know area, for the reclamation of the same area, other technologies needs much more higher cost. But the problem is only with this technology is little bit time consuming, because you can see here also, this is time taking process. And also it depends on the crops, and it depends on the efficiency of the plants. It depends on the contamination level where we are going to remove. So the problem, what is the problem? Why means I have selected this plant, Ricinus communis, and even for my research purposes also, because when the phytoremediation, the concept of phytoremediation has emerged, so the scientists tried to explore the potential of different plants to extract the metals without, many times without considering the ecological concerns, ecological consequences, as well as contamination of the food chain. So we can see here number of plants, edible crops have been targeted, and Brassica gentiana is well-known hyperaccumulator plant, which is targeted for the number of metals and got the highest citation, means highest papers published on Brassica gentiana in respect with the phytoremediation. Although it is, a number of plants we can see here, Helianthus, Gcms. So these all are Rhiza sativa, even edible crops. If we are cultivating the edible crops for the removal of heavy metals, so we can assume how much risk is involved to contaminate the food chain. And even many plants are also not much feasible. Oryza sativa, for example, if you cultivate Oryza sativa into the contaminated land, so what are the feasibilities to grow there? Because it is not necessary if there is contamination, so the soil is good, having good amount of the nutrients, good amount of other parameters that can support the plant. Many times contaminated lands are barren lands, salinity affected, drought affected, so these plants have susceptibility to grow there. Therefore, means I just selected a targeted Ricinus communis. It is well known, industrially important plant, because its oil is also using into the biodiesel production, having fantastic composition of different organic substances, which make its oil very important, and not only for the biodiesel but also medicinal purposes. And India is also one of the means leading castor producing country. So for example, in this study we tried to compare with the means compare the resinous communist phytoremediation potential, cadmium removal potential of resinous communis in comparison with the brassica gensea, because brassica gensea, as I told, that it is well known hyperaccumulator plant, so that I just selected this crop as a model crop. And the results we can see here, because at the same time, means when we compared with the brassica gensea, so we found that a very significant amount of the cadmium is accumulated into the resinous communis in comparison with the brassica gensea, because at the same time it produces high biomass, very high biomass. So overall, the level of means metal accumulation was much more higher. Similar in case of the nickel accumulation, because nickel is also a potentially toxic substance. So we can here we can see also the concentration of the nickel was accumulated or present into the uh, roots as well as shoots is much higher than in comparison with the brassica gensea, which is showing with the red colored line, and the green color is showing with the resinous communis. So we can see, uh, but of course, we cannot compare with the biomass, but at the same time, if we are cultivating two crops and taking same time, and when we, of course, the rate of this accumulation of both cadmium and nickel was higher into the brassica gensea, but when we calculate total cadmium and nickel accumulation, it was much higher, because resinous communis produced very high biomass in comparison with the brassica gensea. Similarly, I cultivated the both the crops into the salinity and drought affected areas having cadmium contamination. And here we can also found that brassica gensea is showing the yellow line and resinous communis white. So here we can see also the accumulation rate of cadmium was much higher, even though it was present cultivated into the salinity or drought, because resinous communis we can see, we can easily cultivate it into the harsh conditions, and therefore the objective was to test its feasibility, to test its ability to be cultivated there in the presence of multiple stress conditions. And here means it performed much better than the brassica gensea. Then again, I tried to use some organic and inorganic amendments to find out or to check the efficiency, means check the impact of these organic and inorganic amendments on the accumulation of cadmium into the brassica and resinous communis. So yes, in both the crops, when we compared with the without any addition, without any amendment, both the crops accumulated much higher. But it again was found that it depends on the types of amendment. For example, in this case we can see inorganic, means addition of the inorganic fertilizer urea and DAP, which was the recommended dose, shown the much we can say better results in comparison with the control, that is T1 here. So, and of course in both the crops, as I told, but the total, or we can say overall, accumulation of cadmium in both the roots and shoots was much higher into the resinous communis, because when we use certain amendments, they enhance the growth first. overall growth, whether it is the fresh and dry biomass, root number, shoot number, whatever. So the overall, we can say, accumulation was increased, of course, in both the plants, but the overall accumulation, which was our target, that whether the application of inorganic and organic fertilizers can be enhanced. Yes, it was enhanced in both the crops, but it was enhanced in resinous communis much higher. Again, we targeted how much, what is the defense system of this crop, because uh, this is wild crop. So it is assumed that it has also good defense system, because it can be cultivated any condition, any place. So in this objective, I targeted that how the, it means, in presence of the cadmium, what is the response of this resinous communis in terms of the antioxidant defense system, in comparison with the Brassica gensea. So it was more or less, we can say, parallel or more or less similar with the Brassica gensea. Of course, like in terms of the proline, MTA, glyethyl peroxidase. So we can say it has good defense system in terms of the antioxidant enzymes, and which makes this crop again much more means I used this crop, and also tried to check the impact of a mild contamination of cadmium on the yield as well as accumulation of cadmium into the seeds, because seed is the usable product. And if there is contamination, there is accumulation of the metals, translocation of the metals, cadmium or nickel into the seeds. So it is quite not easy to select this crop, because when we use the oil, so it will again come into the oil. So we just means I cultivated this resinous communis singly into the mild contamination of cadmium, and the results were also very surprising. The yield was also means not much. There was no significant difference when the cadmium contamination was 17.50 milligram per kilogram soil, and in comparison with the control here, not comparison with the brassica here, but means the transfer of cadmium into the seed was very insignificant. I think it is in, yes, in this table. The accumulation of cadmium into the roots was much higher. Lower stem, upper stem, primary leaves, secondary leaves, fruits cover and seeds. So the cadmium was, of course, accumulated in very significant amount into the roots, and good translocation also, but it was very high because 1 year old plant, and upper stem, lower stem. So significantly, we can see there was reducing concentration into when we are going to upwards, or we can say from roots to the seeds and into the seed, which was our main target to check whether it is means cadmium is translocating into the seeds. And it was, of course, it's very negligible amount, and therefore this feature also make this crop is very fantastic, and this crop very much suitable for the phytoremediation purposes, because it is non-palatable, even not eaten by the any animal also. Non-palatable, not non-edible, even non-palatable, because insects, even, of course, few insects like earthworm, feed the leaves of this plant, but it is cultivated for different purpose at that time. And yes, biotranslocation factor, as we move from the roots to the seeds, it is continuously decreasing. Of course, for the phytoremediation purposes, biotranslocation factor is also very important feature. If the biotranslocation factor is higher, then we can say the plant is much suitable. But if our target, our motto is that we can use the product, we can use the seeds of any crop. So if there is no accumulation, there is no any translocation of the cadmium metal, so it is more, good, more better than the accumulation of the um, translocation of the metals into the aerial parts. So we can say when we are moving towards the seeds, the concentration is reducing continuously. Number of other studies have also been conducted, and it also again enhance the soil fertility parameters when we cultivate the resinous communis into the soil. This is study of Wu et al. 2012, and they found that they shown that before resinous communis cultivation and after resinous communis cultivation, after 1 year, the soil parameters and compared the soil parameters and found significant enhancement or significantly change the soil properties, soil physicochemical characteristics. Nutrient content and castor meal and husk. After extraction of the oil, the castor cake and husk has also very significant amount of the soil plant nutrients like nitrogen, phosphorus, potassium, calcium, magnesium. So the castor cake and husk can also be used for the as a biomanure. But yes, we have to check at the final, because we already checked that it's very insignificant amount, so it can be easily used for the purpose. But if we are cultivating this crop for the removal of any other metal, so we have to check once after extraction of the oil into the castor cake and husk, whether it is the toxic metal is not there, then we can misuse as a biomanure also. Number of studies have been conducted to find out to explore its potentiality of resinous communis in different concentration of the metals, in different metals conditions, different, even mining contaminated sites also, pesticide contaminated sites also. And all the studies have indicating that this plant can be utilized for the phytoremediation purposes. And overall, we can say that cultivation of resinous communis can develop eco-sustainability, because resinous communis, as in this figure we can see here, this plant is using for the agriculture, restoration of the degraded land, of course phytoremediation, fertilizer as a biomanure, means castor husk and cake can be used as a biomanure, pharmaceutical industry, biofuel production, societal development, carbon sequestration, of course, because it's a high biomass yielding plant, industrial products, and agriculture. Agriculture is also very important, and I think future prospects also mean scientists can look forward, because if we are cultivating this crop and the metal is not going in a significant amount into the leaves, and that the same leaves can be feeded, can be used for the agriculture, means same plant can be used for the agriculture. So this phytoremediation can be integrated with the agriculture also. And of course, some biotechnological interventions can also be incorporated, can also be done to accelerate its the accumulation of contaminants. It accelerates the accumulation of heavy metals, especially smooth recovery of metals from the harvested biomass is also a challenging task, but because if you are cultivating crops at a very small level, so it is quite tough, because it again make this process costly, which is a merit of the system. So extraction of the smooth recovery of the metals, but at this commercial level we can use some metallurgical processes so that the metals can be extracted, but of course it will again need some more money. To assess the impact of metal on oil quality and quantity, means in future also directions, means this research can be performed to assess, to analyze the impact of cadmium, for example, on the oil quality, whether means it is changing the quality of oil or as well as quantity of oil, because we have already analyzed the yield, but there is no much more significant difference, much more significant impact. But in case of the oil also, because which is the final product of this crop, it can again be assessed. So with these words, uh, I say thank you very much. Thank you for your attention. And if someone needs any means to ask any question or needs any query and even suggestion, so please, over to you, Miss Patil.
Yes, sir. Thank you so much, sir, for sharing your deep knowledge with us. Thank you so much. Now, moving question. Um,
Thank you, sir, for the wonderful presentation explaining the role of plants in the biodegradation of the toxic chemicals present in the soil. Thank you very much, sir. The session was uh, an excellent one, informative and enlightening for all the scholars and the audience. Thank you very much, sir.
Oh, welcome. Thank you.
Thank you very much, Kuldeep Babu sir. Now, I request to Dr. Sorish Bhattacharya to deliver the plenary lecture as a speaker of the session. And the topic of this plenary lecture is Circular Economy Model for Bioremediation of Industrial Waste Water through Biorefinery Approach. Now, I would like to invite Dr. Nisar Rishi as the chairperson of the today's session. Over to you, sir.
Good afternoon, sir.
Yeah, good afternoon. I am audible, right?
Yes, sir, you're audible. Thank you, sir,
Yeah.
for joining us. I'm pleased to introduce Dr. Sorish Bhattacharya. Dr. Sarish is a senior scientist at Process Design and Engineering Cell, CSIR, Central Salt and Marine Chemicals Research Institute, Bhavanagar, India. Dr. Bhattacharya has completed his PhD from Central Salt and Marine Chemical Research Institute, MTech in Fermentation Technology from IIT Bombay, and BTech from West Bengal University of Technology. Dr. Bhattacharya has a strong research background in the field of microalgal biotechnology, microalgal biofuel, biopolymers, and nutraceuticals. Sir has authored 25 research papers in reputed national and international journals, has 15 book chapters to his credit, and 3 patents as well. We are pleased to have you, sir, today with us as an expert speaker. I kindly request you, sir, to proceed with your presentation. Over to you, sir.
Yeah, thank you, Dr. Nisar. First of all, I would like to thank all the conveners and the committee members for arranging such a nice conference, and also means thanks for giving me the opportunity to deliver a talk related to the bioremediation approach for various textile and other industrial wastewater. So I will just share my presentation now.
Sir, please share your presentation.
Yeah, it is getting uploaded, I think. Actually, I don't know, means it is showing that uh, now the slides are audible. Sorry, the slides are visible.
Yes, sir, it is visible now.
Sir, you can keep your PPT open, then come to the StreamYard, screen
Okay,
share,
okay.
and now it is
I
visible.
think,
I can see the screen now,
yeah,
sir.
yeah.
Please proceed.
Okay. Uh, good afternoon, everyone. The title of my talk is a cost effective, sustainable process for microalgal based gamma lilolenic acid production from microalgae through biorefinery approach. So, basically, we at CSMCRI we are dealing with the algal based process wherein we use microalgae as an culture to treat various effluents involved, uh, textile wastewater or any of the wastewater from dairy industries as well as fishery industries. So basically microalgae provides a various solution to the problems that you can see, like in the thermal power plant we have emissions of carbon dioxide, then NOx, SOx, etc. And simultaneously there are various wastewater which can release heavy metals that are containing nitrogen, phosphorus and other as well, which causes a great pollution to the environment. So uh, no, means lot of peoples are working on various other remediation techniques, but anyways we are trying microalgae to provide a biorefinery approach, because the microalgae at means means can do a simultaneous means can the microalgae support us in developing an integrated process in which at one attempt we can do the bioremediation process, and in other attempt we can generate the products like animal feeds, biofuels, nutraceuticals, etc. So coming to one of the case study wherein we have used textile wastewater as our source material for growing microalgae. So you can see that using the textile wastewater, we can grow the microalgae at a very ease. Means the textile wastewater is containing various nutrient source that can be utilized for the microalgal growth, and the treatment cost was something near about to 2.43 to 3 rupees per meter cube. So using this wastewater, we can generate sufficient good amount of microalgal biomass, and it can be easily sold out at a cost of 10 rupees per kg. And out of this microalgal biomass we can process it further for lipid extractions, which is a again a source for producing biodiesel, and the residual uh, microalgal lipids can be purified further for generating high value products such as gamma linolenic acid. So again means after extracting all these things, the de-oiled biomass that is left over can be processed further for chemoenzymatic hydrolysis, and we can develop biopolymers, bioethanols and other value added products out of it. And you can just see that after 6 days, the dyes present in those textile wastewater are completely getting remediated. So at one instance, we are not only solving the issue of the bioremediation, but simultaneously we are developing value added products which can reduce the treatment cost as well. So it would be means a profitable business for the industries as well, um, wherein means not only the this wastewater will be treated, but at the simultaneously they can generate revenue out of selling the products being generated during the process. So then is the this mass balance fluxogram, wherein you can see that, sorry, I think the slides were not moving na. Okay, yeah. So this is the mass balance fluxogram, wherein we can see the list of components that have been generated from the uh, process. Like means after harvesting of the biomass, we are getting sufficient good quantity of total lipids, which can be processed further for gamma linolenic acid purification, and the residual oil can be processed further for biodiesel production. So here you can see that means we can say around 5 to 7% of GLA, which is quite a good amount of product we can see. And out of this also, means after the complete extraction and purification of the products, the residual biomass is being processed further for generating a nutraceuticals, means a protein rich product. You can see around 10% of the total proteins are being extracted from the biomass, and which is having a good value. So basically we are developing a complete ZLD process, wherein each and every byproduct is being utilized in the process. Um, so even means after the residual biomass left over from after getting the proteins out of it, we are processing it for the chemi enzymatic hydrolysis. And through the chemi enzymatic hydrolysis, the um, residue, the hydrolyzate that is being obtained, it is being processed for microbial fermentation, wherein we are using a strain of bacillus licheniformis to generate two simultaneous biopolymers. One is epsilon polylysine, which is a well known natural food preservative, and another product is polyhydroxy alkonoid, which is a well known bioplaster. I will be coming back to it. So so the uh, uh, so you can see in the downstream process as well that we are going with the single step urea fractionation for purifying the gamma linolenic acid from the total lipid being obtained. Okay, so next case study is the bioremediation of fishery wastewater. So in this, we have to again utilize fishery wastewater as a nutrient media to grow one of our strain of Chlorella vulgaris, which was used for generating various products. So you can see that once the Chlorella vulgaris was grown at a bench scale, we have gone with the large scale microalgal cultivations, wherein the production age is around of 12 days. So microalgae grows very well in this wastewater, and the biomass that is being generated is quite of good quality and also of the uh, food grade quality. So this microalgal biomass was again then processed for the total lipids extractions, and from the total lipids we have purified astaxanthin out of it, and the non-polar fractions, means which is the residual oil being obtained after the astaxanthin recovery, is being processed for non-polar lipids fraction, because non-polar lipids fraction can be directly diverted for the biodiesel productions. Now again for the value addition, the biodiesel byproducts, that is the crude glycerol and uh, the hydrolysate of the biomass, can be processed again for the biopolymers. For example, bioplastics, means the phs can be produced using hydrolysate prepared through the chemoenzymatic process. this is the whole, again, the material balance, you can say, wherein production age for microalgal cultivation is 15 days. This is quite more as compared to the textile wastewater, because the nutrient flora of the fishery wastewater is slightly different. So the harvesting can be done after the 15 days, and then we have utilized this microalgal biomass for total lipids extractions, wherein the non-polar fractions can be diverted for the biodiesel production, and the other part was diverted for astaxanthin and zeaxanthin production. Astaxanthin and zeaxanthin is very well known nutraceutical products, and nowadays there are a lot of products being used. For example, lot of multivitamins are using these products in their formulation. So coming into the E factor, the E factor is also means in the comparable range, and we can say that this is a green process, and the cost of uh, astaxanthin at commercial scale is quite high. So obviously this product at commercial scale can generate sufficient revenue um, through bioremediation as well. So coming into the last approach means wherein the biodiesel byproducts can be effectively used for producing two biopolymers, that is polylysine and polyhydroxyalkanoate. So we have isolated a novel strain of bacillus lecaniformis from our experimental salt farm, which can utilize crude glycerol in the fermentation and produce polylysine and polyhydroxyalkanoate, both in the same fermentation process. Like after the fermentation, the polylysine is being produced extracellularly and polyhydroxyalkanoate are produced intracellularly. So these are the media composition for it. This is the NMR profile and the carbon utilization efficiency by Bacillus liquoriformis. These are the characterizations data. Same the NMR profile, which is confirming that it is the polyhydroxyalkanoate is P3HB. So that's all. Thank you very much. And if there are any queries or any question, I would be happy to answer them.
Thank you so much, sir, for your valuable guidance and sharing your deep knowledge and delighting us. Thank you so much.
Thank you, sir, for the wonderful presentation
Thank you,
revolving
Nisar.
around the algal uh, biotechnology. Thank you very much, sir. It was really interesting and the anchoring one. I hope the students, it will help the students and young researchers to pick up the thread from your research. Thank you very much, sir. We don't have any questions from the audience. Thank you, sir. Thanks a lot for being with us today. Thank you, sir.
Thank you. Thank you.
No questions from the audience now.
Thank you, Dr.
Uh, Thank you, sir.
Thank you.
Now, I request to Dr. Subhajit Singh to deliver the lecture as the speaker of the session, and the topic for his lecture is adsorption, kinetic and thermodynamic behavior of chromium 6 by novel GeoUIO66 naphthalene dicarboxylic acid nanocomposite. Now, I would again request to Dr. Nisar Reshi to chairperson of the session. Over to Dr. Visaresh.
Good afternoon, sir.
Good afternoon.
Thank you, sir, for joining us. Briefly, Dr. Simranjit Singh is a postdoctoral researcher at Indian Institute of Science, Bangalore. He is working in the Interdisciplinary Center for Water Research. Previously, Dr. Singh has worked as a project scientist at Punjab Biotechnology Incubator, Mohali. Sir has been conferred twice with the Young Scientist Award. Dr. Singh has authored more than 97 research and review articles in the journals of national and international repute. So there is authored 48 book chapters. Dr. Singh is an active member of various scientific societies and organizations like Asian Chemical Society. Sir, we are pleased to have you today with us as an expert speaker. I kindly request you, sir, to proceed with your presentation whenever you are ready, sir. Over to you, sir.
A very good afternoon to one and all. Myself, Dr. Simranjit Singh, working as a postdoc fellow in the Center of Interdisciplinary Center for Water and Advanced Research. I am working under the supervision of Professor P.C. Ramamurthy, Department of Material Engineering, Indian Sciences of Bangalore. My area of expertise ranges to environmental remediation, and the topic of my presentation is adsorption, kinetic, and thermodynamic behavior of chromium 6 by novel MOF-based nanocomposite. So, first of all, I will share my slides. Share screen. Okay, then, this one. Stop. Hello, are my slides visible? Hello, hello.
Sir, visible. Yes, sir, it is visible.
Okay. Thank you, ma'am. Thank you.
Okay, sir.
Okay, let's start with a brief introduction on the chromium. Chromium is one of the major environmental contaminants that elicits carcinogenicity, toxicity, and natural prevalence. It is regarded as the seventh most abundant element in the Earth crust, having an atomic number of 24. It is introduced into the ecosystem through both anthropogenic and natural processes. Natural processes includes weathering of rocks. The weathering of the rocks commonly caused soil formation, which is a natural process that introduces chromium into the ecosystems. Mostly chromium is found into two different oxidation states, chromium 3 and chromium 6. Among these two oxidation states, chromium 6 is the most predominant form. So, due to the increasing groundwater contamination by chromium, it directly enters into the ecosystem through plants and hence the food chain, making its way into the human body. Chromium has reported to accumulate in the plants and it affects the various metabolic processes like nitrogen metabolism, photosynthesis, which ultimately lead to a reduction in the yield and the productivity. So there are various health problems which are related to the chromium contamination, or the we can say there are different health problems in animals which are associated with chromium exposures, which include the dermatological, respiratory, and cardiovascular issues. It is also responsible for various lung diseases, skin lesions, hypertensions, polyneuropathy, and various peripheral vascular diseases like anemia and other gastrointestinal malfunctions. So, chronic poisoning of chromium has been linked to the generation of reactive oxygen species, which results in the formation of tumor generation and DNA impairment. So, despite this fact, the toxic effects of chromium, about 1/5 of the whole population are subjected to chromium contaminated drinking water. Due to practical limitations in quantification and the removal of chromium in PPB regions, WHO has provisionally set a guideline value of 50 ppb as the permissible limit of drinking water. So the major problem statement here is that the hexavalent chromiums exhibit high solubility, and therefore its removal from the environment is quite difficult. Various treatment processes have been reported and investigated for the removal of chromium from environmental matrices. They include biological and physiochemical processes. Biological processes include phytoremediation, biosorption, whereas physiochemical processes involves oxidation, membrane separation, coagulation, ion exchange, precipitation, and adsorption methods. Out of these methods, adsorption methods have been considered as an effective remediation technologies for the chromium removal. So different adsorbents such as carbon-based materials, clay-based adsorbents, metal oxides, aluminum-based adsorbents have been reported till date for the removal of chromium through the adsorption processes. So these approaches are based upon the effectual transfer of metal analytes to the adsorbent material that depends on the analyte-sorbent interactions during the adsorption processes. So in this study, we have selected MOFs for the removal of chromium-6 from the wastewater. Actually, MOFs are the hybrid inorganic organic porous compounds which comprises of a regular array of metal ions bounded by linker molecules. The major advantages of MOFs is that they offer unique structural diversities as compared with different porous materials owing to their high structural uniformity, uniform pore structure, tunable porosity, extensive varieties, flexibilities in geometry, chemical functionality, network dimensions, and topology. So the main intention of this study is to evaluate the ability of the novel synthesized MOF-based nanocomposite by combining the advantages of graphene oxide, UiO 66 NDC nanocomposite for the removal of chromium. So the key objectives of this study include to synthesize the MOF-based nanocomposite using different approaches like sorbothermal and wet oxidation processes. Second one, to assess the effects of the nanocomposites on the different parameters like initial ion concentration, pH, dose efficiency. Third one is the insight into the removal mechanism, on which mechanism the removal process is based. And the fourth one is the different isotherms, kinetics, and thermodynamics for understanding the nature of the adsorption process. So first of all, we will move to the synthesis of the nanocomposites. In this, we have used two different processes. First one is for the synthesis of GO. So for the synthesis of GO, we have used the modified Hammer's method. In the next step, what we have done, we have taken a weight percentage of GO in a DMF, and we have sonicated the samples for more than 8 hours. In each GO solution, we have mixed a known amount of zirconium chloride and left for stirring for overnight. After that, we have added the H2NDC to the above mixture, and we mixed the whole solutions completely. Then we transfer the mixture into a Teflon liner with a stainless steel autoclave and heated it for 24 hours at 120 degrees Celsius. After the solvothermal reactions, we allowed the composite to cool down at room temperature. Then we centrifuge the whole solutions and wash the material with different amounts of DMF and ethanol several times. Finally, the dry product was constant weight to at 85 degrees Celsius. So this is the first figure which shows the point of zero charge. That simply means what is the charge on the surface of the nanocomposites. So this figure represents the point of zero charge on the surface of the nanocomposites, which is found to be 5.32. This value represents that chromium adsorption is more favorable at pH values above point of zero charge, where anion form of chromium adsorption is more favorable at pH values below point of zero charge. So this could be due to the significant electrostatic interaction between the protonated oxygen and anions containing functional groups which are present on the surface of the nanocomposites. So after a point of zero charge, we characterize the materials using different techniques. In this figure, we can see there is the FTR spectra and the XRD spectrum of the nanocomposites before and after the experiments. So the FTR spectrum of nanocomposites were recorded before and after the chromium adsorption. The carboxylic groups OH present at the 3355, it completely suppresses the sp2ch resonances. However, after chromium 6 adsorption, the OH resonance completely is diminished. The anti-symmetric stretching and the symmetric stretching resonance of carboxylate groups are also identifiable. Noticeably, the antisymmetric stretching at 1557 here 1557 shifts to the 1568 after chromium adsorption, which is possibly due to the interaction between the possibly due to interaction with the chromate ion. Other molecules that CH and C double bond CH bending vibrations appear around 785 and 650 respectively. So second one is the Porter XRD analysis of the nanocomposite sample shows that the materials are amorphous in nature. Several crystalline resonance corresponding to the metal organic frameworks were also observed. They appear as very faint peaks on the top of the amorphous halo. The amorphous nature complements to the adsorption properties, providing defect sites for the heavy metal adsorption. The sharp resonance degree near 7 here is the characteristic peak of graphene oxide. After adsorption of chromium 6, the sharp peak of the nanocomposites gets completely suppressed by the broad amorphous resonance confirming the adsorption process. So this figure, sorry. So this figure represents the FESM and EDEX of the nanocomposite before and after the studies, adsorption studies. The structures appears as numerous irregular nanoparticles fused together, forming an extensively porous framework resembling microporous polymers. The morphology has in several large and small crystalline particles with sharp edges, which, which agrees with the XRD data. EDS analysis of the nanocomposites is primarily composed of carbon dioxide with 19% weight of zirconium. The SEM and the EDS analysis were also performed post-adsorption experiments. The micrograph depicts an absorbable change in the surface morphology after the chromium studies. The surface appears to be less porous with smoother edges as a result of chromium particles get embedded on the surface of the nanocomposite. So from the EDS analysis, we also confirms the successful impregnation of the chromium on the nanocomposite matrix. So these are the graphs for the BAT surface BAT studies in which we have find that the nanocomposites had a surface area of 279.95 meters squares per gram, which is comparatively high among other research counterparts, and it has a mesoporous structures of around 20.27 nanometers according to the nitrogen adsorption desorption studies. The pore volume of the nanocomposites is observed to be primarily 0.279. After the BT experiments, the pore volume and the surface area shows a significant decrease. The successful adsorption on the nanocomposite is made obvious by the reduction of pore volume and surface area. After a point, there is a continuous increase in the nanocomposites, the maximum values of gas observed. After this, we have checked the optimization studies for the adsorption process. Figure 4 represents the effect of pH. The increase in the removal efficiency and the adsorption capacity were recorded during when the pH increased from 2 to 3. Both the adsorption capacity as well as the removal efficiency subsequently decreases at pH above 3. Figure 5 represents the effect of dosage were examined on the adsorption of chromium 6 by changing the dose from 0.5 to 2.5. This figure illustrates the effect of the adsorbent dose on the removal efficiency as well as on the adsorption capacity. On the increase in the adsorbent dose from 0.5 to 2.5, an increase in removal efficiency was also observed. The highest value of chromium 6 removal was recorded at 2.5 gram per liter of the adsorbent dose. The effect of initial chromium concentration on the adsorption by using the nano composite was carried out by changing the initial ion concentration from 10 ppm to 50 ppm, which depicts the effect of changing the chromium ions concentrations on adsorption. It was seen that nano composite represents better adsorption percentages for chromium 6 at lower concentration. At high concentration, saturation in the nano composite was observed since percentage removal becomes constant. This results suggest that the potential of the nanocomposite on chromium 6 adsorption directly depends on the presence of the enable sites and the functional groups which is present in the nanocomposites. So, in order to understand the adsorption behavior, various adsorption models, adsorption kinetics have been used for this adsorption studies. Out of six different studies, our our studies is best fitted to pseudo second order type kinetics, type 1 and type 2. It is seen that the R square value for both the models, pseudo second order type 2 and type 3, is slightly higher than the other models. Both the models shows higher regression coefficient greater than 0.99. In other words, this data implies that a chemosorption process which involves valency forces through exchange or sharing of electrons between the chromium and the nanocomposites. This represents that the adsorption of chromium onto MOF nanocomposites depends upon the initial concentration of the ions. For adsorption isotherms modeling, we have used three different models, Langmuir, Freundlich, and Temkins. Out of these three models, Langmuir gives better R coefficient values than the Freundlich and the Temkin models. The data obtained from the equilibrium parameter of Langmuir and Freundlich and Temkin is represented in table which indicates the favorable adsorption. In this study, the adsorption of chromium 6 on nanoparticles can be considered favorable according to the isotherms used. This implies that the initial adsorption is governed by chemosorptions, which agrees with the Langmuir isotherms. Following this, further multilayer adsorption occurs in the accordance with the Freundlich isotherms at the higher concentration of chromiums. In other models like Temkin, SIPS, the value of adsorption instantly depicts the unfavorable heterogeneous processes. The influence of four different temperatures on the adsorption behavior of chromium onto nanocomposite were also checked. Here we can see the increase in temperature from 298 to 318. There is a decrease in the values in the values of the adsorption capacities. A decrease in these values with an increase in temperature demonstrate that the good adsorption capacity and removal efficiency was observed at 25 degrees Celsius. Positive values of del H and del S represents that the increasing randomness and the endothermic nature of the process during adsorption. Then moving towards the conclusion. So in this present work, a new nanocomposites have been developed to adsorb the chromium 6 ions from the contaminated water solutions. To this, we have successfully synthesized MOF-based nanocomposites, and the UIO66 was functionalized with zirconium chloride, graphene oxide, and denoted as a GO UIO66 NDC nanocomposite. The synthesized nanocomposites serves as an excellent adsorbent and represents with one of the highest chromium adsorption capacities ever reported. Additional experiments such as the influence of different adsorption parameters such as dose, ion concentration, pH was also carried out to determine the best adsorption results. Here we also demonstrate that the novel nanocomposites has high reusability and regeneration cycles as compared to previously reported data. Further, this nanocomposites achieved an outstanding chromium 6 adsorption capacity of 157.23 mg per gram at pH 3. This is the best chromium 6 adsorption capacity reported till date, which is almost much higher than other reported synthetic and commercial adsorbents. The extremely porous structure incorporating zirconium oxide clusters provided a great contact area and more active sites in the unit space, allowing the nanocomposites to have a high adsorption capacity than most typical nanoparticle adsorbents. So this nanocomposites could be promising advanced. We can use it as a promising advanced adsorbent in the removal of chromium 6 from wastewater also due to its owing to its having high adsorption percentage towards the chromium removal. So finally, I would like to thank the Interdisciplinary Center for Water Research and ISC for providing such grant in the form of IOE ISC Fellowship number IEREC 20013 Bangalore for carrying out this experiment. And I am also thankful and grateful to the organizers, to all the organizers of this wonderful conference, especially the registrars from the Sandip University and all the person and all the other persons involved, and also to the Society for the Green and the Green Environment, which has provided me this opportunity to represent my work at this platform. Thank you.
Thank you so much, sir. Thank you very much for sharing your knowledge with us and delighting us. Uh, One question from our side. Does the adsorption kinetic will be same in the biological organic nanocomposites as in the chromium adsorption?
Ma'am, actually, the biological nanocomposites have a very much regeneration, very much low regeneration capabilities as compared to this synthesized mob-based nanocomposites, and also it is having a very high adsorption capacities of 157.23 mg per gram, which is almost higher to all the reported all the reported low cost adsorbents like previously reported MOF components and other chemically nanocomposites.
Okay, thank you, sir. Thank you so much.
Thank you.
Now I request to Dr. Soumya Pandit to deliver the plenary lecture as a speaker of the session. And the topic of his lecture is investigating the performance of the therapies derived the biochar based anode for improve the power output in a microbial fuel cell application. So I again like to invite Dr. Nisar Reshi as the chairperson of session. Over to Dr. Nisar Reshi.
Good afternoon, sir.
Good afternoon.
Thank you, sir. Thank you for joining us. Briefly,
Thank you.
Dr. Soumya Pandit is currently working as Assistant Professor, Department of Life Science, Shada University, Noida. Dr. Pandit has completed his PhD from IIT Kharagpur in 2015 and carried out his postdoctoral research from Zuckerberg Institute of Water Research, Israel. Dr. Pandit is also a recipient of postdoctoral fellowship from Northwest University, South Africa. Dr. Pandit has authored about 40 research papers in the journals of national and international repute. Thank you, sir. We are privileged to have you us today as an expert speaker on this occasion of the 3D International Conference. Thank you, sir, for being with us. I kindly request you, sir, to proceed with your presentation as and when you are ready. Over to you, sir.
Thank you. I have to share my screen, right? Because I try to upload my
Do
PPT, but it's
you,
still showing
sir,
processing.
what can you do is you keep your PPT open, sir. Then go to the StreamYard. You can click on the share, and then you can share the slide. It is just like Google Meet, the way you
Yeah.
can share your slide. Please open
Okay.
your slides.
Yes. Can you see
Now
the
go to
slides?
this. No, no. Now come to the slides. Now come to the screen share on the StreamYard,
I have
and
already
you.
shared the screen. Is
Yes,
it
sir.
okay,
Yes, sir.
sir?
Yes. Wait a minute. Yes, it is now visible. Yes, sir.
Okay.
Please,
Okay.
please go ahead with your presentation, sir. Thank you.
Thank you. Thank you very much, Dr. Nisar. Uh, I'm Dr. Somu Pandit, and thank you for this opportunity. I would like to thank Dr. Pankaj and Dr. Vinit and Dr. Nisar for arranging this international conference on a very important topic, that is current trends in waste treatment, reuse, and valorization, which is a need of our hour. So today I am going to present a topic that is entitled Biochar-based anode materials using datura pills for microbial fuel cell application. So is it visible? My like uh, slides are visible, sir?
Yes, sir. Yes, sir. It's visible. Visible, sir.
Okay. Okay, thank you. So before I start about microbial fuel cell, let me tell you that why this microbial fuel cell is pertinent. This is pertinent because of that water energy nexus, that we have a lack of fuels which is utilized as a power source, and at the same time there is a problem with water, and at the and we need clean water, and there is a requirement for wastewater treatment, and we have a technology which is drawing nowadays a lot of attraction, that is microbial fuel cell, which can solve both the issues. Now, what are the saline feature in microbial fuel cell? It is, we can consider as a sustainable technology, because we have used wastewater and we have used bacteria here. The bacteria is responsible for the production of direct electricity, that is DC electricity. Now how it works, it is basically nothing but a anode, or it is basically nothing but a battery. Rather we can say it's a biobattery, where on the surface of the anode it forms a kind of biofilm, and it produces electrons and protons during its respiration. The electrons is passing through the wire from the external circuit, while the proton is percolating from the ion exchange membrane, and that gets absorbed, that gets react with the oxygen to form, to complete the circuit, to form water, and eventually on the top we can get electricity, and that electricity is a DC electricity, so that is quite useful. So there's a lot of application, therefore, like we can use the indirectly bio hydrogen, we can desalinate wastewater, we can use it as a BOT biosensor, all are related to wastewater treatment. If you consider it as a energy conversion tool, we can see that you can, if we can use MFC stack, okay, we can utilize biomass and we can generate electricity, and that sounds very good. And why it is more good? Because it has a very high conversion efficiency of more than 80%, while in case of biohydrogen it is 50 to 30%. In case of biogas, particularly methane, it is 25%. So our main job is, like, we are now moving from conventional engine to the PM proton exchange membrane based fuel stack, and finally we have to move with MFC stack, where we can utilize electricity, and with a single step we can generate bioelectricity. So there are, bacteria is the more major concern, because it is basically responsible for the change, or rather conversion of the waste or any kind of biodegradable material in the present in the anode to the electricity. So if you see that in the initial period we used a mediator in order to extract electron out of these things which take part in respiration, but later on we found there are two types of bacteria. One is mediator driven bacteria, like pseudomonas, which produces pyrovatin type of molecule, and which eventually donates their electron and reduces the anode, and as a result the anode get negative in charge. And there are other type of bacteria which form biofilm on the surface of the membrane. Pseudomonas is also a type of bacteria which also form biofilm on the surface of the membrane and eventually donates their electron via cytochrome C molecule. That is their basic biochemistry. So if you try to understand that biochemical pathway, we can see that inside the cytoplasm, this particular bacteria oxidize the substrate, and that substrate generates electron, and then electron gets transported by defined types of electron transporter like NADH dehydrogenase quinone protein, then periplasmic plasma protein, and then outermost cytochrome C, and eventually it will make the anode very negative. So when crores of bacteria inside the biofilm will start donating their electron simply because they need to continue their respiration, okay, it becomes negative. So if the cathode or the surface uh, of the electrode which is positive, then there is a electrode potential difference, and we are eventually using the potential difference and generating the bioelectricity. And let me tell you, this type of bacteria can work only under anaerobic condition, because oxygen is not their terminal electron acceptor. Rather, metal, oxidized metal, or other oxidized some fermentative molecule, or mostly oxidized sulfate is their terminal electron acceptor. So under the condition when we put this bacteria inside the anode, it start donating their electron. So we used a single chamber microbial fuel cell in this particular studies, and you can see that it is nothing but a simple vessel where we inserted a electrode, and we have a membrane cathode assembly, and we have used it for bioelectricity production. So the voltage variation that we can expect per reactor is 1.1 volt, considering the anodic half cell potential is 320 and cathodic half cell potential is 840 millivolt respectively, as oxygen act as a terminal electron acceptor, and the substrate that we would like to utilize, for example acetate wastewater, butyric acid, or whatever the wastewater is, complex starchy wastewater, or any kind of biodegradable material we can use. So by and large we can expect around 1.1 volt theoretically, but in practical we get much less voltage simply because of the fact that there is some kind of internal resistance. And we say it impedance because this is not a this simply not maintain the Ohm's law. Here ion as well as electron moves from solution, there will be interface, and as a result we need to improve the we need to overcome the over potential or the voltage losses, and that is our major challenge. So if you see, there are different types of voltage losses that occur during the operation. One is activation over potential, then ohmic over potential, which is not that much a problem, then concentration over potential, which is again a very serious issue. That means the issue mainly for anode purpose is where we fail to produce good amount of biofilm. As a part of biotechnologist, our job is to promote biofilm on the surface of the anode, so much so that it can donate maximum electron, and even if we put a very low resistance, we can harvest maximum amount of energy, so the kinetics of respiration will be very fast. So in other way, our job is to promote electroactive biofilm on the surface in a better manner. So if you see the kinetics of the anode, it is very slow indeed. Okay, through the anolyte there is a problem of diffusion, so we need to produce better biofilm formation, particularly electroactive biofilm formation, which is kind of monolayer, and eventually we can expect that we can get better power density at a lower applied resistance. So if you see the kinetics, it is very fast compared to a MFC, which is a microbial fuel cell, and PEM is nothing but a proton exchange membrane based fuel cell, where the kinetics is very fast. So proton diffusion, fuel oxidation, electron transfer to the electrode, and instability in voltage generation is the main problem here. Our job is here, not much information is available on the modification of graphite surface, particularly with biochar. Then So here our plan is that we know that biochar is basically helps in increasing the overall surface by volume ratio, and it has good capacity, it is a good capacity material. So our hypothesis is that it may be compatible to the microbes and it may form better biofilm. So we have done physicochemical characterization of the biochar based on the carbon electrodes, assessment of the biofilm formation on defined biochar, and evaluation of power output and coulombic efficiency on defined graphite paper. So we have used basically we have to synthesize the cost effective biochar, which is a part of our physics lab. Dr. Minal Gupta helped me in this regard. Mostly here I will focus on that performance in microbial fuel cell. So to evaluate the biochar based anode for microbial fuel cell, and to evaluate the biofilm formation using confocal laser scanning microscopy. So the hypothesis that we have is, as I told you, that since it is bit hydrophobic in nature, and it will have a very rough surface, then there is a chance that the biofilm formation will be much better on this kind of surface, and that is our hypothesis. And according based can you see the screen, sir?
Yes, sir. Yes.
Sorry for I didn't notice that. Sorry for this interruption.
No, 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 no problem, sir.
So I don't know from where I need to start. Can you tell me from where I stopped? It stopped.
Yes.
This one from this
Yes,
hypothesis.
sir.
Did I
Yes, sir.
explain? Yes. Okay.
No, sir, it's
So
remaining. Yes.
okay. So our hypothesis is that we that that if we incorporated, if we impregnated biochar on the or coat it on the surface of the anode, and then there is a possibility then that more amount of biofilm can be produced, and it helps in proliferation. So we prepared biochar like in a typical uh, tube oven, and we took datura pills in this time, and we have washed it and dried it, then crushed it into the powder. Then after pre-treatment with ethanol, and use the pre-treated precursor, and we activate it with KOH, and then we perform the carbonization in a tube furnace at 100 degrees centigrade under nitrogenous conditions. Then we use like lower pH, and then we washed it, and finally we got the activated biochar. Then we performed the FESM study and other studies um, like FTR and XPS. And then using a spray gun, we try to uniformly spray it on the surface of the anode, that is a PAPX graphite electrode. So this is the microbial fuel cell, and we prepared this microbial fuel cell using uh, uh, using that like one as a negative like anode, like that is without any kind of biochar, and there are other anode which contains defined concentration of biochar from 0 mg per centimeter square to 1 mg per centimeter square, and we have used a synthetic assisted wastewater as as an inoculum. We use Pseudomonas aeruginosa MPCC, and you can see here that model organism that we used, and that PAPX flexible graphite plate used, we purchased it from Marsen. So we have done population study. We have also performed current interruption method, cyclic voltammetry in order to check its capacitive activity, and electrochemical impedance spectroscopy. So you can see here that the globular spherical part which helps in S by V ratio, and then I'm going to the main results. We found that at a uh, at a maximum power density that we have achieved at 1 gram per centimeter square, which is not very much significant, where there is no much significant difference with 0.75 milligram per centimeter square of biochar. We got around 600 milliwatt 600 milliwatt per meter square, per centimeter square, sorry. And so we try to check that cyclic voltammetry, and we found that in case of cyclic voltammetry, it was around 60 farad per gram, and then we try to perform that electrochemical impedance spectroscopy, and we found that the charge transfer resistance significantly decreases when we used 0.75 or 1 milligram per centimeter square of biochar. We tried to perform the Coulombic efficiency, and we found that the Coulombic efficiency also helps in Coulombic efficiency also increases with the increase of the biochar on the surface of the anode. It was initially 9.5, and later it was increased up to 13. Then we tried to perform the biofilm analysis, and we found that there is a significant total amount of biofilm. We used cytonine for live cells, propydium iodide for dead cells, and Alexa fluor tagged with fluorescence molecule we have used for EPS production, and we found although EPS is bit non-conductive, but we found that with the increase in the biochar, there is a significant amount of electroactive biofilm formation on the top of the surface of the anode, and that we scratched, and we perform confocal laser scanning microscopy, and from that we have analyzed all these things. Regarding biofilm analysis, when we use a software like Immobilization, and we found that it's a clear evidence that in case of 1 milligram per centimeter square of this kind of anode, this kind of biochar coated anode, we get maximum amount of biofilm. So in an indirect manner, we found that apart from TIFF image analysis with Comstat, as well as with Imaris software, both says that biofilm formation, that this kind of biochar promotes biofilm formation, mostly due to its rough surface as well as its hydrophobicity. It lured the bacteria to form biofilm. It helps in adhesion and form biofilm, which also says that it is quite compatible, and it can be a very good electrode material which is conductive. Most of the material which we used are non-conductive. This one will be conductive. Hydrophobicity is already reported, which is it is hydrophobic, and obviously it produces rough surface. As a result, we got better performance. So maximum open circuit potential is also high. We can see in terms of watt per meter cube, that is volumetric power density, it is also relatively high, say 7.26 compared to 2.30, almost 3.5 times higher compared to graphite sheet based electrode without any kind of biochar. We can see that Coulombic efficiency average In batch studies of 36 hours, it was 73.23%, and charge transfer resistance significantly increases from 172 to 94 while we use this kind of biochar. So the conclusion is that like biochar decorated anode promotes more biofilm. Obviously, that highest power density is 7.3 watt per meter cube. That biofilm volume of the electroactive biofilm was found almost 3 times higher. Maximum coulombic efficiency is found 13.46 with an average of 9, which is much higher. And then we have a biofilm that electrochemical impedance spectroscopy is also results suggest that it is also better in terms of reducing the charge transfer coefficient. That means that whenever that it is that electron is releasing from the microbial cell surface to the anode, it is actually reducing the resistance. So we would like to thank Sharda University for seed grant, as well as DRDO for sponsoring this research. Thank you.
Thank you very much, sir. Thank you for delighting us and sharing your deep knowledge with us. Thank you so much.
Thank you, ma'am. So recently we published this paper in Fuel, and we have some extra data also. So if you have any question, please you can ask me.
Yes, sir. Now, any questions from the participants?
Okay. Thank you once again.
Thank you, sir. Thank you so much.
Thank you very much.
Thank you. And now I request to Professor M. More to deliver the lecture.
Can you hear me?
Yes, sir.
Yes, sir.
Sure, sure. So,
Good evening, sir.
good evening.
Thank you, sir, for joining us. Briefly, I would like to give your introduction. Professor Nandkishore More is an associate professor in the Department of Environmental Science, Babasaheb Ambedkar Central University, Lucknow. Uh, Professor More has a vast experience of teaching and research in the field of environmental toxicology, pollution, natural ecosystem, biodiversity, sustainable development, eco-restoration, conservation, and problems of global and Indian environment. Thank you, sir, for being with us today. It's a privilege to have you on this occasion of international conference. I request you, sir, kindly proceed with your presentation whenever you are
Yes,
ready,
sure.
sir. Over to you, sir.
Okay.
Thank you.
Yeah. I'll just share my slide, that's all.
Sir, you just open your PPT, then go to the StreamYard, wherein you can see the second option from the right, share option, from where you can share
Yes.
your PPT.
Excuse me. Yeah, Pankaj was calling up. I am on the share side. I have already gone to entire screen. I should share, I suppose.
You
A
can
window.
share entire screen also. Window, both will work, sir. Both work.
Okay. It should come. It should come. Just a minute, please. Yeah, it is there, I think. Can you see it? Can you see the first slide,
Yes,
please?
yes, sir, yes, sir, yes, sir. Please go to the slideshow, sir, so that
Go to
I can see
slideshow.
your screen, sir.
That I should go to the cup.
Slideshow, yes, sir. That's the slideshow.
Okay, so friends, it's I must thank Sandip University for hosting this international conference and the Society for Green Environment for taking a risk of inviting me to deliver a talk. And I am being an environmental professional working in the field of environmental science. I wish to focus on certain things, which are very important to us. The city of Nashik is a city of wine. It's a wine city, and it is basically. Yeah, I'm in the talk now. I'm engaged. After half an hour. After half an hour, please. So, sorry for the interruption. It is Pankaj only was there. Yes. So, what are the eco-friendly biomaterials, and can it be a green approach to textile wastewater treatment? Now you see there are two things that eco-friendly biomaterials is a term which I am using is exclusively relates to the use of the waste which is generated after the fruits are utilized. So this is one that but second one is that can we have a remediation of textile wastewater, which is another or the second industry which is polluting next to paper and pulp. So let me share with you some few informations related to the food loss and waste. The technology that we are talking about is basically the conversion of waste into useful one.
Sir, we can only see your first slide. Can you please move your slide, next and third slide?
Shall I go back?
We can only see your slide one, eco-friendly material. The first slide is only visible, sir.
So I'll hide it and then I'll go back.
You can click on the next slide, and or you can see on the right side of your system, sir. There's one cup-like structure, which means slideshow.
Yeah, it
You
is
can
there.
please click on the slideshow so that
No,
you can
but
easily navigate.
is it done? Is it
No,
moving?
sir.
Not moving?
Not yet. Not yet.
I'll hide it, I'll go back. I'll stop and I'll again restart.
Okay, sir. Okay, sir.
I'll stop
You can
again
join
and
again,
I'll
sir.
re. Now it is done.
Wait a minute, just I need to check it out.
Is it this? Shall I? Oh, oh.
No, sir, you have to
Technology.
share the screen.
So I'll go back to share. Now I'll go with the up and lower icon to move the slide. That's all. Nisar?
Yes, sir. Sir, I can't see your screen. Wait a minute, sir. I just need to hold. I need to add your screen to this.
Can you see it now? No, I'm happy you're using some new software for screening and all. But maybe because of that new software, there is some difficulty. Systems are not well
Sir,
compatible. Yes.
so now, sir, your screen is visible now. You please go to slideshow. Please go to slideshow, then you can easily navigate to the next slide.
I'm in a slideshow only.
On the left side, you can see the slide itself. On the left side, you can click on the next slide. Next slide, this is how many you can navigate through the slides.
No, you're not
Please
able to
proceed,
see.
sir. We are only able to see your slide number one.
But not slides.
First slide.
You can see the third slide.
Yes, now it is visible now. Yes, sir. Please proceed, sir.
No, I think I will not. Can you see this at least? Then if I go to the full screen, there is difficulty, I think.
Sir, it is visible now. I can see the next slide. And we can proceed from here. It is okay now, sir. We can navigate. We can see the next slide.
Shall I go to slideshow now?
You can go to slideshow now, sir. If you are okay with that, you can go. But however, in this mode also, we can see your next slide.
Oh, I see. No, let me just. Now I am on the key facts on food loss and waste. Can you see that slide?
Yes, sir. Yes.
So, are the alphabets visible there?
Yes, sir. The slide is visible. You can proceed in this mode only, sir.
No, because the moment I go to the full show, no, then there is a difficulty, it seems.
You can proceed like this, sir. You can see the screen slides. It is clear.
Now I can go for slideshow.
You can proceed like this also, sir. The slides are clear, sir.
Okay. So there are two important issues pertaining to one is the wastewater and the second one is the food loss and wastage. So the most important thing is roughly 1/3 of the food produced in the world for human consumption every year, approximately 1.3 billion tons gets lost or wasted. This is huge. Secondly, if you quantify in terms of economic measures, economic terms, then it amounts to almost like $700 billion US dollars. This happens in the developed countries, but not only in the developed countries, but even in the developing countries too. Almost to the half of that is lost, wasted in the developing countries. Secondly, the industrialized and developing countries dissipate almost the equal quantity of food, which is also very huge loss. So, friends, if the fruits, vegetables, roots, tubers, we are losing them as a food, and there is a huge population which is without food. So, there is a dilemma. Secondly, the industrial waste which is generated is also, on one hand, it is making our life unsustainable. So the only issue which is left to us is, on one hand, we save our food. Second hand, when the food its losses, the waste are converted into something useful. And then the third one is the industries which are parallelly being developed, and they are generating their wastewater when it is reaches to the nearest ecosystem, the treatment of it. But there is a link that we should be able to develop now, because we are in a technology era. If you look at it, that the food loss and waste per year in terms of cereals, in terms of crops, fruits and vegetables, which I'll be more focusing on this, because our bioabsorbents that I'll be talking at the end of this talk will be exclusively made from the fruit waste. And the city of Nashik is, as I said, it is city of wine. So can we explore a possibility of a project or a collaboration where we can ensure that even no fruit and its waste, its byproducts, do not go back, as a waste. It gets converted into something useful, or at least for the environmental cleanup. This is the basic concept. Now let me make some story for this, that why. That, if you look at it in terms of the consumer ratio, so if you look at it at the amount of food produced and the food used, then it is also very significant. In case of developed countries, it is like this. It is like almost like 222 million tons it is consumed. When it comes to the food produced, and in countries it is consumed and produced, there is a huge difference. Meaning, leave aside that the discount of the waste which is generated. So 230 million is just produced in the sub-Saharan Africa. It is another big continent physically. So the amount of food lost or wasted every year is equivalent to almost half of the world's annual cereal crops, in terms of cereal crops. Well, let me come back to how the fruit on the fruit side in the next slides. So let me go to the next one. Before that, let me tell you that how much per individual we would be consuming. So per capita waste by consumer is in between 100 to 115 kilogram per year in case of Europe, or in North America including Canada, while consumers in sub-Saharan Africa, South Asia, Southeastern Asia, it is almost like just 10% of it. So you can imagine now, if that continues, the disparity on one hand, the sustainability, the right to food is also on the other hand, and environmental cleanup is the trinity. So the total food production for human consumption is about 900 kilogram in a year in developed countries, whereas it is almost like half in case of the developing and the undeveloped world. So 40% of the post-harvest losses, and moreover, the processing in industrialized countries, which is almost like tuned to the tune of 40%, also happens at the retail and consumer level. So we are losing huge amount of the crop. We are losing the huge amount of our energy into losses. So this is very serious concern. Now let's look into the statistics of it, that when we use, in case of the fruit production in countries worldwide, and then how much they are using. If you look at the countries and their contribution to the production of fruit, then definitely the China is the number one in that case. Of course, it is countries like US produces 5%, and they contribute 5%. India contributes to the tune of 12%. 12.49 is in Pacific terms, whereas China produces 20.39. So there is a potential in our own domain, to utilize the fruit and fruit wastes. So how we can do it? Yes, it is generated when 40% of it is lost. Now, how much amount of the fruits that are produced are generally going back as a waste? Let's see the list. Next slide. Now, if you look at this, that per capita food losses and waste at consumption and pre-consumption stages in different regions, then there is a huge difference you can see. So for example, in case of, this is a small slide, there is a connection here. Could not connect to the stream. Am I connected? Hello? Hello?
Yes, sir. Yes, sir. We can hear you, sir. Your screen is visible. Your audio is okay, clear, sir.
Okay, that's good. That's good. Just look at this slide just to make one point, that is, you see, if you compare it with the amount which is consumed and the amount which is produced, is that makes a story much clear now, that how to convert it into useful one then. So this is per capita food losses and waste per kilogram per year. The brown one is for consumer, and then in the blue one, the sky blue one, is from production to retailing. Now if you compare it with this South Asia and Southeast Asia, then you see the amount which is produced and goes to the consumer, and the one which is from production to retailing is huge. So very little goes to the consumer in that sense. That means on one hand we are generating more waste, on the other hand we are getting less out of it. This is the point that I want to drive. The second point which I want to drive is this. If you look at this global flow by commodity wise, you see, for consumption, for distribution, for processing, for post harvesting, and the actual production in the fields. Then in case of fruits and vegetables, it is quite significant. In case of cereals, yes, it is consumption is good. In case of fruits and vegetables, the losses is also very significant, as you can see, because mostly the livestock is perishable, and this is, we have this FAO program for save food, just to ensure, the food for all, the right to food and food security. So this is one area that we are all talking about now. I'll not take much time because I have only 30 minutes as was slot given to me. Now I'll go to the next slide. That if you look at this with reference to the footprint, that how much is the waste and how much is the carbon emission. So the carbon footprint is rising on one hand, because any solid waste which is generated will have a positive impact on the, meaning negative in that sense it is positive, because it will add to the carbon footprint. You are emitting more and more carbon dioxide, carbon monoxide, and certain dirty dozens, what we call as a pollutants. So what is the solution? So let me have some experiments shown to you, so that we can say that can we convert it into something useful, and what are the engineering measures that we can apply. So let me have something, the most important part that which I will be looking forward now to is that the textile and the wastewater, the effluents of the textile is also very important for us. Textile is a wastewater which is used after processing textile products, and the water generated after first, second, third or use is a wastewater in any case. So any water which is once used first or second or third, and when it goes back to any of the nearest ecosystem, it's a wastewater, or if it is treated well and good, otherwise it goes as it is. So these textile industries have increased significantly. Secondly, not only the textile industry as such, but the use of dyes, the most synthetic dyes, the complex, and even the organic dyes as a coloring material is on rise. Almost like 20% of the synthetic textile dyes, they enter the vital environmental segments through effluents. So therefore, the generation of colored wastewater is an issue. If it is a clean wastewater, sunlight will penetrate through it, then the biotic component will continue to use it, then there will be inflow and outflow of material cycle in case of viable ecosystem, then it's okay. But if it is not happening, then it becomes a stagnant ecosystem, and therefore there are cases of eutrophication and certain things which are already been talked by the earlier speakers. So then therefore it is used. So textile industry is for washing of fibers to bleaching, mercerizing, dyeing, printing. The whole array of processes which are used definitely needs washes, because and then this wastewater generation is quite significant. And look at it, in the next slide. If you look at the dyes, that we can use it for, then the type of dye that we can use, in case of woolen, we'll use acid dyes. In case of cotton, we'll use azo dyes. In case of paper, we use very fundamental basic dyes. And even for cotton also, we use the dyes directly. Sometimes polyester, we use the dispersion method of dyeing. But then even for the food and cosmetics also we have dyes, and there are different kinds of dyes which are used for various purposes, including paint and plastics. But the one which I am referring is the initial one, the textile one. Now let's go back to what I was saying. It's leaching into aquifer, therefore the pollution of groundwater is important. So what could be the management practice that could be employed to? So the growing concern, for environmental protection has also led to certain important issues of health as well. Most of the dyes which are used, they have severe health issues, starting from nausea, vomiting, headache to stomach pain, to many of them are teratogenic, mutagenic, and carcinogenic. And some have given rise to respiratory dysfunction in the reports which are reported for this textile wastewater. So the issue is, can we at least remove the color that in one case, because dyeing is important. Dye are reaching into our riverine ecosystem, and therefore there is issue of not only environmental pollution, but it is also an health hazard. So the prime concern is to at least to ensure that the excessive dyes which are going into the aquatic milieu, at least they can be limited. So the one control measure is to remove the color of the wastewater. And the first and foremost thing that we can think of is the biological material, because most of the chemical treatment processes are not easy. Not only easy, but they are economically not feasible. So the first, we tried to do few experiments to remove the color from textile effluent by using some adsorbent material. We used our own natural waste of the fruits like banana pseudostem, banana peel, orange peel, pomegranate peel, and leaf of banana. So, and also to see whether it can be utilized, for removal and their percentage efficacy of removal of the dyes from the textile wastewater. I am not showing the details of what is the physico-chemical characteristic of the textile wastewater. You all know that as per APHA and for CPCB standard, they are all beyond the permissible limits. That I am not going to waste time in discussing all those things. I'll simply explain these two experiments of mine and certain engineering measures that we can apply for it. I am already in the middle of my talk, so I'll be making more points more clearer now. The third one is we wanted to optimize the efficiency of color removal using the fruit peels against different engineered parameters. So the effort was to see whether these are all biological materials. None of them are synthetic. But however, we are using it against the waste which is basically generated from the use of synthetic materials. So we have this another way to look at it. So this is the slide which tells us, the sample that we used, that the banana pseudostem. Peels of banana are abundant. Orange peels are abundant in a city of Nagpur. Pomegranates are very much abundant in the belt near Nashik and up to Thana and nearby. Banana leaf is very common because the North Maharashtra is full of banana plantations. So, but the waste is also generated at the same time. So you see, Let's see, in the next slide, when we will have collaboration with the Sandip University, I will add one more component of maybe raisins, that the grape waste, after it is extracted for wine and some beverage purposes. So that is next that I will look forward to have collaboration with you and then add some value to our knowledge in that area. Now let us see, if you look at the characteristics, I am simply just to tell that these are the chemical characteristics of it and the values which we are considering now here. For example, it's composite textile wastewater as these, if you take a sample, the TDS is somewhere close to 3000. The chloride levels are very high. TSS is around 15,000 to 8,000. And then you see even the COD also is around 15,000 to 12,000. And BOD is as usual, it is 6,000 to 8,000. This is a differently put slide, but I am just explaining it to you. Now, if you look at it now, what we did, these peels were dried up in the oven and their adsorbents and the granules were prepared, and they were tried under experimental conditions. So first is we prepared adsorbents out of it and then allowed, by allowing the wastewater to flow through it, and then did the batch absorption experiment for dye removal, and then looked forward to certain adsorption, that is a physical parameter, that adsorption as a process. Now if you look at the result, it shows like this, that these were used, it was done basically using spectroscopy initially, and then later on now we are doing it through FTIR and the others. So according to Ministry of Environment and Forest, there are some limits even for the discharge, but it is also doubled. But then when we used our adsorbents, and when we looked at that their adsorption parameters using the standard isotherms, then we found these values. So first is by monitoring or modeling pH, we found that what is the percentage of the dye which is removed. So we found that when the pH was modulated, then the pH of the effluent, as it was it altered the physicochemical properties of the water, and which had adverse effect. But we realized that the maximum color of the textile wastewater, because the methylene blue was used as a standard dye for removal of the color efficiency, for the color removal efficiency. So the maximum removal of color from wastewater was observed at 7 pH by all the adsorbent used in the study. This is the removal of dye based on pH using the adsorbents which we prepared from this indicates. Now, how to know whether they are really...
Sir, we are running out of the time.
Yeah, I think this is last slides. Now 2 slides.
Thank you. Thank you, sir.
Last 2 slides. Now, how this contact time, meaning if you retain this adsorbent for more hours or more duration, does it really go for removal of the dyes? And then yes, we realize yes, it changes from 30 minutes to 45 minutes. And most of them are in the range of 30 to 45, but some of these waste, adsorbent generated from this waste, fruit peel waste, they were more effective. Third one is about when we worked out on the absorption isotherm, particularly Langmuir and Freundlich, we found their values were within range. Say in the next slide. So if you look at the Langmuir and Freundlich isotherm values, in case of banana pseudostem, it happens to be almost 0.9 net. And when we looked into the comparative dye removal efficiency of adsorbents, we realized that the pseudostem was almost like 95% at a time interval of 30 minutes, and the dose concentration, the adsorbent dose concentration of 0.06 gram. was almost 95%, but it varied from 85% to 95%. Banana leaves we found low. We found the potential in pomegranate peels and banana peels, and then you see now this is where we realize that lastly, can we really convert something which is waste otherwise thrown away? Even the banana is considered to be a nuisance in case of the railway signaling systems. So to conclude, in 2 points that you see that we can modulate the parameters and use even the waste which is generated in the farmyard also, even as a cleanup substrate for environmental cleanup. So, and I see that there is a potential for us to use them as the bioadsorbents, because we have used only two isotherms, Friendly and Langmuir. We can do some more engineering parameters and then look forward to a better sustainable future, because biomaterials have a longer future for not only for food safety, food security, but also for environmental cleanup. Thank you very much. Thank you. Thank you, Nisa.
So much, sir.
Yeah,
Thank
yes,
you very much for sharing your knowledge with us.
welcome. You're welcome.
It's
You're
really
welcome.
informative session for us, sir. Thank you.
Any query, anything, if it is there, I'll there. All right.
Okay, good evening, everyone. Now we will now start with the oral and poster presentations. I request to Dr. Sharmila Gangle to present his poster.
Dr. Nisar, am I audible to everyone?
Yes, ma'am, you're audible.
Okay. So, ma'am, should I share my screen?
Yes, yes, please, ma'am. Just a minute. Is it okay?
Okay, okay.
Okay.
Good evening, everyone. This is Dr. Sharmila Gangale, Assistant Professor, Department of Biotechnology, C.K. Thakur College, Panvel, Navi Mumbai. Welcome all for the presentation on the research topic Pseudomonas aeruginosa, the eco-sustainable tool for bioremediation of mercury. I heartily appreciate the efforts taken by the Sandip University on the theme of waste management, recovery, and the solution for the eco-sustainability and environment. So based on that, I would like to present some of my research work based on the eco-sustainability. So the title of my research is Pseudomonas aeruginosa. It is the name of the organism and its contribution related to the bioremediation. Next slide, please. In a very short, I would like to express the abstract of my study. Basically, heavy metals is one of the important cause of concern globally. Heavy metal emanates from anthropogenic as well as natural activities in several environmental compartments. From the last few decades, the mercury pollution poses a serious health and environmental threats due to the long-term non-biodegradable nature. To deal with this issue, bioremediation is a very effective process as compared to the other physicochemical methods The present research work introduces and emphasizes an eco friendly technique like bioremediation to sequester heavy metals like mercury ions from the wastewater by employing a selected metal tolerant bacterial isolates. So, here I would like to say that the treatment which has been proposed by the bioremediation techniques are really helpful by the base selected bacterial isolates, and during bioremediation isolated pseudomonas aeruginosa showed a noteworthy ability to reduce the mercury pollution. Moreover, this technique has been confirmed by means of whatever the treated effluent has been there. It showed a significant growth on tritium astrium seeds and shows a really a great growth of the plants which frequently farmers can able to take in their farms. So by this we can able to show that there are certain agricultural applications which can be used for the irrigation of various essential crops. Next slide please. Heavy metal pollution is the major cause of concern today. Heavy metal causes a hazardous impact on health of living organisms. So, why heavy metals are very much important, and why it is uh, need to be removed from the environment? That is the big threat of environment, and it is a first thing is non-biological in nature, and second they are highly toxic even at a small concentration. So, the various heavy metals like lead, mercury, zinc are basically not at all required by the living body. You can take flora and fauna of like from the community of water, air, and as well as the amphibians. Nobody, and including the human beings, nobody want the heavy metals as a source of uh, any kind of the food material. But though they are highly toxic even at a small concentration. Next. Next slide, ma'am. So, what is mercury is? Mercury is basically a 12th element which is there in the periodic table, and which is going to be used to rule out with the help of bioremediation technique. What is bioremediation? Basically, the technique which employs a microorganism complex toxic pollutant into the simpler form. It's not like that they are going to totally eliminate
Ma'am,
the
your voice is breaking.
pollutants, but
Hello?
definitely. Okay, okay, ma'am. Am I audible now?
Yes, you're audible, but your voice is breaking.
Okay, okay. So bioremediation is a techniques which employs the microorganism to
Okay.
transform the complex toxic pollutants into simple form. The term bioremediation refers the environment help for the living organisms like plants, microbes, algae, fungus, etc. Bioremediation is an effective technique over other conventional method because they are actually carried out for the pollutant degradation as it does not harm the environment. It's a eco-friendly method. That is one of the important advantage of bioremediation without creating the
Ma'am,
hazardous
please conclude within the time, okay? You have only 4 minutes
yes,
present yourself.
yes. Please, next slide. The aim of my research is to investigate the ability of Pseudomonas aeruginosa for the bioremediation of mercury. The simple objective I will going to discuss in the next slide. Next, ma'am. Next slide, ma'am. Bioremediation is a biological process, employs microorganism. It is comparatively economical and it utilizes the toxic heavy metals as a source of nutrition. The these are the results which able to gives you the ma'am. I think it's so far. Yeah. Okay. Okay, ma'am. That's it. So these are the research has started with the screening, sample collection, and after that we have optimized the parameter for metal bioremediation, in which the effect of pH growth effects will be studied. So I have maintained the pH of the microorganism; those they can give. You can see in the picture that pH has been maintained up to 6 to 7, which is able to work in that particular environmental condition, so the microorganism can able to survive. So microorganisms are optimized on that particular stage. Next slide, ma'am. Next slide. Optimization parameter. After that, the growth parameters are also studied. Growth pattern of waste isolates. As the mercuries, the concentration of the mercury increases, the growth of the microorganism increases, and they can able to take it up as a metabolic activity. Next slide, ma'am. Characterization will be done. So best selected isolates like HgI3 for the mercury were identified by Burgess manual, and it seems to be a Pseudomonas aeruginosa, which is confirmed by Vitek identification. Next slide, ma'am. These are some of the heavy metals which have been isolated, gives the best result out of it. Next. This is the result of ITEC identification, which shows that the isolated bacterial isolate shows a 99.9% similarity with the Pseudomonas aeruginosa, which confirms that this is the bioremediation study of heavy metal. Not only mercury, but also lead, zinc, and other mixed metals can be ruled out. Morphological studies proves that the morphological, physiological, and biochemical characterization of the best bacterial isolates were performed successfully, and AgI3 is belonging to the genus Pseudomonas aeruginosa, belonging to this particular microorganism. Next slide, ma'am. So afterwards, the result has been carried out. The percent seed germination by treated and untreated industrial water, which has been given with the help of Pseudomonas aeruginosa, they shows that maize, green gram, moth beans, coffee seeds, horsebeam seeds, and fenugreek seeds can able to grow in a manner that they should be with the help of treated water. You can see that it is highly related to the control as such. The seed germination is also being carried out with the help of this treated industrial samples. So this is a germination study. Next slide, ma'am. So in the next one is here is the pot culture test, which you can able to see. It shows highly appreciable results with the control one, and this is the way that Pseudomonas aeruginosa can able to treat the water in a manner it should, or it can be used for the irrigation purposes. Next slide, ma'am. So research outcomes are the enzyme study proves that enzymes plays an important role in bioremediation of heavy metals. As the remediation increases, it will gives the better results. These are some of the references I have been used. And next slide, ma'am. Next slide, ma'am. Next slide, ma'am. Thank you so much for giving me opportunity, Sandip University team. I'm really thankful to everyone. Thank you, Sangeeta ma'am.
Thank you so much, ma'am. Thank you. Now I request to Kunal Rajput to present his poster. Kunal Rajput, over to you.
My name is Kunal Rajput from School of Science, Sandip University. And my presentation is Biomedical Waste Management. Next slide, ma'am. Next slide, ma'am. What is a biomedical waste management? Biomedical waste, ma'am, fast होते हैं. Biomedical waste is defined as any waste which is ma'am next immunize of human being or animals or research activities. Ma'am next slide. Sources of biomedical waste is including hospital, nursing homes, laboratories, clinics, office and densities. Next slide, ma'am. How to dispose of my biomedical waste is a segregate in a 5 color in bags in yellow. Second step is the collection of the biomedical waste, and ma'am next slide. And third step is the storage of the biomedical waste. Secure adapted temporary waste storage space allocation is vital. Waste storage is time should be limited 24 to 48 hours. And fourth step is transportation. Proper personal protective equipment supplies to easily cleanable sealed containers such as the plastic buckets, trolleys, or is transport waste from there. Ma'am, next slide. And fifth step is a treatment. If the protected device allocation is vital, is the best and cost-effective treatment option should be selected based on the National Environment Protection Regulation. Next slide, ma'am. Next slide, ma'am. Dispose waste. Dispose waste is according with the requirement of its applicable national, international registration establish a system separate disposal of the different types of waste. Next slide, ma'am. Thank you very much, ma'am. Thank you very much, ma'am.
Thank you, Kunal. Okay. Now I request to Dimple Patil to present her poster. Dimple, over to you.
You are going to share the screen?
Ma'am, please do share your screen.
Okay.
Okay.
Ma'am, my PPT is there na, with you? Because it seems to be difficult to open PPT.
No, ma'am. Please click on the share.
Just a minute, ma'am.
Yes. You have only 4 minutes to present yourself.
Yeah. Madam, can I take afterward?
Okay, okay.
Yeah.
Okay. Now I request to Machindra Nikan.
Yes, ma'am, can I audible?
Yes, you're audible.
I will share my screen.
Yes, sir. Please share.
my slides are visible, ma'am?
No, sir, just a minute, sir. Yes.
Is my first slide visible, ma'am?
Yes, sir, it's visible now. Please continue.
Okay, okay. Thank you, ma'am. Thank you, ma'am.
You
Thank
having
you to
only
Sandip
4 minutes, sir.
University. Okay, ma'am. All the team to give me chance for presentation. Let's start with introduction. uh, what is the problem nowadays? The dairy farming is the dominant sector of whole economy. During this practice, millions of tons domestic animal waste product are formed. In this waste product, cow urine is the major waste product. Because of cow urine is the decomposed after 15 or 13 minutes because of several factors. Which factors are there? Microorganism like chemical and aromatic compounds, degradation, cellular and amorphous material in cow urine present. So this is need something processing. So, so processing of cow urine into cow urine distillate is the step to overcome the problem of environmental pollution caused by storage of cow urine in dairy farming. This is also helps to increase the stability of cow urine distillate than cow urine. This study aims to determine the quality of cow urine in the form of cow urine distillate and its antimicrobial property and increase the environmentally friendly surrounding in this sector. And also in Ayurveda, the use of cow urine for medicinal purpose is well documented. The cow urine has been used for several purposes such as medicine, antiseptic, and agriculture. And in present days, some research on cow urine distillate also going in relation with bioenhancer or protecting and repairing DNA from oxidative damage, immunomodulation, and some research having good results in anti-cancer activity also. In this work, cow urine distillate obtained by distillation process was tested against the pathogen responsible for causing urinary tract pathogens. Next slide. Uh, in this whole work, our work divided into two parts: distillation of cow urine, and they check the antimicrobial property of cow urine distillate. Then, how do the collect? We collect the sample from Nashik Vasalya Goshala, then in using sterile container. Uh, then next, methods of distillation. These are the very important methods because there are several methods to distillate cow urine, like indirect heat flask with electric power method. Then second one is direct heating using earthen pot method. And next is the which is using by us heating using pharma grade stainless steel with the thermic fluid for distillation method. At the because we use indirect heating method because direct heat causes the protein and chemical changes in cow urine and their properties. At the low temperature around 70 or 80 degrees Celsius, at the temperature no major changes in the chemical composition. This is a uh, due to we choose the indirect heating method. Next, this is the flowchart showing how overall work we can conduct. First, sampling of cow urine, and then distillation, and then microorganism which tested against distillate. They are grow on suitable agar plate and performing their isolation. Next, in this slide, this is another one flowchart: antimicrobial activity by agar well diffusion method. So in this flowchart, first we take the media that MH agar, then grow the Mulan inter agar plates with appropriate temperature, optimum temperature. Then we tested against the organism that causing urinary tract infection with the cow urine distillate. So plates were incubated for 24 hours at 37 degrees Celsius, and zone of inhibition in millimeter diameter were shown. Next slide. uh, in this observation and results, we tested 41 urine samples of pathogens having UTI. In that, 30 are males, 11 are females. From these 41 samples, we obtained 21 gram positive isolates and 20 are gram negative isolates. Next, in this last table, average shows the average zone of inhibition against the UTI microorganism. Let's see some pictures of inhibition zone. This is the inhibition zone against the E. coli. This is Pseudomonas aeruginosa, Streptococcus faecalis, Staphylococcus aureus. This is the average zone of inhibition against UD, against the identified microorganism. Next slide, discussion. In this result table, we reveal that out of 41 patients investigated for UTI, 30 were males and 11 were female. Most of males were found infected by Streptococcus faecalis and E. coli, while the least infection was by Staph aureus and Pseudomonas. Most females were found to be infected by Streptococcus faecalis, Pseudomonas, and E. coli. Similar result we represented by these MacLean and Thomas Houghton. Among the diabetic patient, urine sample Streptococcus faecalis and E. coli were identified maximum than other identified microorganisms like Pseudomonas and Staph. Similar result were obtained. Next one is the identified bacteria from cow urine sample were treated with cow urine distillate. This is the very important and surprising results we obtained. Zone of inhibition were treated with E. coli is 18.4.
Hello, sir. Please conclude within the time.
Okay, ma'am.
Yes.
Conclusion is based
Okay.
on the result concluded that the identified bacteria urine sample were treated with cow urine. This is a maximum average zone 18.4 and with gram positive Staphylococcus aureus is a 12.6. Cow urine distillate derived from cow urine and dairy farming plant and can be used as a antimicrobial agent in urinary tract organism, and this form of cow urine utilizing environmentally friendly livestock waste. Thank you, ma'am. Thank you to Sandip Foundation, organizer team and society, and giving to chance to participation, and thank to all team.
Thank you, sir. Thank you so much. Now I request to Dimple Patil.
Hello, am I audible?
Yes, you are audible. Yes.
Yes, yes. Good evening, everybody. I'm from Sandip University, Department of Life Science, presenting plastic degrading bacteria. A growing accumulation of plastic waste has become a several environmental and social issues as well. So it is urgent to develop innovative approach for the disposal of plastic waste. So in current years, report on biodegradation of synthetic plastic by microorganisms or enzymes have spring up, and these offer a possibility to develop biological treatment technology for plastic waste. In this review, we have studied some of the plastic degrading bacteria. So I'm going to introduce my topic. So the demand for plastic production are increasing annually despite plastic waste pollution presenting a major global environmental problem, as we all know about that. So actually the plastic or synthetic plastic is a fundamental part of our lives. So the majority of plastic products end up in the landfill. So the amount of many metric tons of plastic waste is generating every day, and how to dispose it, this is a major problem nowadays in front of all. So the majority of plastic products end up in the landfill or dispersed in the environment with inadequate waste management, leading to an estimate 9 to 14 million metric ton of plastic entering the ocean every year. As well as on the top of mountains are already accumulated near about 150 million metric tons. So the even plastic additives such as a phthalate components, that is a polyethylene, uh, that is a polyethylene tetraphthalate, that is a PET, frequently used as a plasticizers, are a major source of concern due to their overuse in the variety of different products and adverse health effect also. So biodegradation is a possible route toward the sustainable management of millions of tons of plastic waste. So the appreciating its simple synthesis, robustness and durability, industrial production of polyethylene tetraphthalate, that is a PT, was launched soon as after its discovery and has been gradually increasing, projected to be over 70 million tons in year 2020. So despite being non-toxic, its large particles are microgranules, accumulate in marine and terrestrial habitats and in living organisms. So recycling of this polyethylene tetraphthalate requires significant amount of energy and occur only in small fractions. So recently, the bacterial stage.
Ma'am, please conclude within the time.
Yeah. So Odorella sequences 201 F6 was discovered and shown to grow on low crystallinity PET film. So about this particular microorganism, Sodinella sequences was first identified in 2016 by a team of researchers led by Koiloda of Kyoto Institute of Technology and Kenji Miyamoto of Kyo University after collecting a sample of PET contaminated sediments near a plastic bottle recycling facility in Japan. So these are the building blocks of polyethylene tetraphthalate, which can be used to produce new batch of PET. So compared to no PET degrading esterase, that is a these are the PETs. These are an esterase class of enzymes that catalyze the hydrolysis of polyethylene tetraphthalate. So from the sequences shows the higher activity at ambient temperature and on highly crystalline PET. So the microbial degradation and metabolization of PET and its degradation intermediate MHET. This is also one of the another enzyme.
Ma'am,
Enzyme
sorry to
which
interrupt you.
degrades plastic.
Please go to the conclusion.
Yeah. So how to degrade this plastic? So the as already discussed, this bacterium employs a two enzyme system, the enzyme system to depolymerize this plastic waste, so which are further catabolized as a carbon and energy source. So this is the bacteria which can be degraded. So these are the enzymes. These are the two different enzymes, esterase enzymes, which generally depolymerize its, and this is the MHET. This is a monohydroxyethylene tetraphthalate hydrolase, which cause which is generally discovered in 2016. So this is the structure, how it get bind and how it give the depolymerization of this molecule. So, what is a viable solution to the plastic problem? So, for the enzyme to be useful, it has to work fast, be mar- uh, be marketable, safe, and deployed. So, where plastic pollution is most abundant. So, if they can degrade hard plastic fast enough, so there are unless in the recycling process. So, a study used so the Therefore, in October 2020, UK scientists combined the two enzymes involved in the plastic breakdown processes and created a more efficient version, as stated before, that could work at the room temperature also. So, we can producing 2070 million tons of plastic waste yearly. So, and the scalable solution need to be found now. So, enzymatic degradation of plastic by bacteria shows huge potential to be a solution to tackle plastic waste problem. So this is little bit what I studied about it. And thank you, Sandip University, for giving me a chance. Thanks to all faculty members for giving me chance to present my PPT. Thank you, ma'am.
Thank you, ma'am. Thank you very much. Okay, now I request to Preeti Chaurasia to present her poster.
Ma'am, am I audible to you?
Yes, ma'am, you're audible.
Okay, ma'am. You might be having my poster there, no?
Yes, ma'am, yes. Over to you, ma'am, please.
Okay, thank you so much, ma'am. A very good
Ma'am, you
evening.
have only 4 minutes, please, okay?
Yes, yes, sure, ma'am. Okay, thanks.
Okay, okay.
Good evening to all the dignitaries present over here and research scholar and students. I, Preeti Chaurasia, research scholar PhD of Nirvan University, and is going to present on the topic microbes as eco-compatible alternative to decolorize the textile effluent. Now, as we know that one of the most in demand and popular and developing industries in India is textile industry, and it is also very important industry in entire the world also, as dyeing fabrics and textiles are famous all over and fulfills the demand. And approximately 1 lakh commercial dyes are available, and more than 700 variety of the dyes and their intermediates are synthesized in India, particularly in the Rajasthan. Rajasthan has more than 4,000 textile manufacturing units, mainly dyeing and bleaching sectors, and particularly Bhilwara, Jaipur, Pali, they are the hub of textile mills. And these industries use complex mixture of dyes to achieve the desired shades, actually the synthetic dyes they use, and the concentration of the dyes that is used in the dye bath is very high, that is around 50 to 300 gram per liters, along with the lots and lots of the chemicals. So during the different processing stages, these industries use large amount of water, and in return they produce large amount of wastewater, and thus play a major role as a global polluters. Now, as we have already known that there are many techniques like physicochemical techniques, that is known as conventional techniques, to degrade these dyes from the water, but these are very costly, and the intermediate product that are produced, they are very harmful. Now, just before that, ma'am, the steps that are involved, the objectives were the isolation and screening, and then coming to its physiochemical analysis, and then its identification using morphological, biochemical, and molecular characterization. So, what is the need of this effluent treatment? Actually, a bit down, ma'am. Now, the effluent treatment is very important because they contain dyes, and even a small percent is the indicator of the pollution there. So it is very harmful, and it can can eventually harm the flora and fauna of the water. And again, if it is consumed by humans or used for irrigation purpose, it can harm the plant, the growth of the plant, the yield, and to human various diseases to the humans. Again, to the top, ma'am, you can see that from there I have isolated 5 strains of the randomly picked the 5 strains from the culture, and these were named as B1 to B5. And the first one was Bacillus ceres. Again, it was the second one was Exubacterium indicum. The third one was Exubacterium ornaticum, and fourth and fifth were the same as Acinetobacter baumannii. The decolorization rate was seen, and the first Bacillus ceres has given a best result at more than 80% of the textile effluent were decolorized. But when I used it with the mixture of the bacteria, or you can say the consortia, the effluent decolorized very well and the water became clear. And you can conclude that from this that the decolorization performance was very higher than that of the individual strains, and that because individual strain in the consortia, they may attack the dye molecule at different position, or they may attack the metabolites produced by the coexisting strain for decomposition, which can result in increased rate of decolorization in comparison to the pure strain, or you can say single strain. So from this, we can say that the future prospect and challenge is that a very efficient and very robust treatment process is needed to treat this textile effluent. And the trend is shifting towards the use of the consortia rather than using the individual strains. And by this we can also treat we can also isolate the native bacteria to treat this textile laden dye laden textile wastewater. And if the results are very good, we can use it commercially by converting in them into the powder or the liquid form, the cleaning of this water, and that can be again reused for the irrigation purpose, as well as we can also use for the treatment of different types of other industrial effluent, and make it and convert them this polluted water into the potable water. And That's all. So my work is still going on, and this is the part of my research work. Thank you so much. Thank you, Sandip University, for giving me this privilege.
Thank you so much, ma'am. Thank you. Now I request to Fatima Zohra.
Ma'am, am I audible?
Yes, ma'am, you're audible.
Yes, yes, ma'am. Hello, everyone.
Ma'am, can you please present yourself, presentation?
Okay, ma'am.
Okay, okay. And you have 4 minutes, ma'am, only, okay?
Okay, ma'am.
Okay.
Just a second.
Please continue.
Ma'am, is my screen is visible?
Yes, visible, ma'am. It's
Okay,
visible.
yes, ma'am. So my topic of presentation is use of a spinach plant through the guided hydroponics and extracting heavy metal from the slugs. Now, so as we all know, like slugs contain effluent which is released from the various sources of industries. Industries like automobile industries, garages is there, domestic waste, lots of different industries waste located in the different residential area, and they release their effluent directly into the water body through a different like drainage pipe gutter is there, nala is there, a small water body which ultimately release in the river or large lakes, and that can cause a change in the pH of water body. In fact, they affect the whole physical and chemical parameters of the body. Like they can disturb the pH, they can change the salinity of the water, they can change the turbidity, hardness of the water, which ultimately disturb the ecosystem or directly or indirectly affect the human health. Now, the effluent which is released from the water body, they contain one of the important pollutant nowadays is heavy metal. Heavy metals, like when we discuss about the heavy metal, so it is one of the major pollutant which is released from the industrial waste or industrial effluent. In this project, we are going to discuss about the treatment of the heavy metal. So, first, like heavy metals have become an increasing threat to the ever rising environmental pollution. We all know like heavy metals have an ability to accumulate in the water body, soils, and groundwater, which ultimately enter into the food chain through like flora and fauna and enter into the human food chain, and they are responsible for causing a various diseases. So my aim of this project is to establish or use the hydroponics. When we discuss about the hydroponics, so it is a one type of methods nowadays, and it is trending in a many countries. Like we can use the hydroponics. What is hydroponics? So like we are like growing the plant or culture the plant. Through the water, we are not using the soil, so that method we can use for the accumulation of heavy metal which is present or released from the effluent into the freshwater bodies. So this is a postulated module. Like first, for doing this project, so when we discuss about the accumulation of heavy metal, so first we have to locate the release point of the heavy metal from where they are releasing into the water body. Then afterward, there we have to locate the that small water body. Maybe it is a small lake or the small stream where the waste are releasing in the water body. Then we have to connect that water body to the location or the growth area or the culture area where we are going to set up our hydroponics model. Now first we have to check the water parameters, like we have to check about the physical pH, temperature of water, their chemical nature, and the type of heavy metal present in the in the water, and amount of heavy metal which are releasing from the effluent. After that, we can, by the help of hydroponics, we can like extract or accumulate the, with the help of phytoremediation we can accumulate the heavy metal which is present in the water, and after that we can treat that module, because like hydroponics nowadays they are using for the like growth of the different plant. So that same concept we can use, and for that like selected a spinach is commonly called as a palak, and after that, after the growth of the spinach, we can air dry or sun dry that spinach. We are not going to use it as a food source, because so then we have to air dry it, and after that we
Ma'am,
can
your
pyrolyze it.
slide is,
Yes, ma'am.
you have only 2 minutes.
uh, okay, ma'am. Just a minute, ma'am. After that, we can pyrolyze the pyrolysis of spinach. So why we are taking the spinach? Because it is cost effective, and it is a quite easy for the growth media, and they have a good ability to absorb the like water content from or water content, and they have a good fast growth rate. So this is my conclusion. Like hydroponics is a newest trend for meeting the agricultural demand of the world population, and they required a small space to be execute. And this model is just like a pre-primary model. We are working on it and designing for execution of a plan. So this is it. Thank you, ma'am. These are some references. Hello.
Yes, ma'am. Thank you. Thank you,
Done,
ma'am.
ma'am.
Thank you
Thank you.
very much.
Thank you, ma'am.
Okay, so we have completed the session 2 of the day 2 of conference. Thank you very much to all speakers, session chair, students, and participants. Sorry, due to some network issue, I'm not able. Sorry for that. So we are completed the session 2 and of day 2 of the conference, and thank you very much to all the speakers, session chairs, and students and participants. So now we continue here. We will meet virtually tomorrow again at 10 a.m. So till then, take care and thank you all of you. Thank you very much.